Sure. Hello and welcome. A very good afternoon to all our students who are logged in for today's session. And today, 20th of July, we are taking up sequence, series and progressions. Dear friends, in the last sessions, we had discussed about permutations and combinations. Today and for the next session, we shall be focusing on series, sequence and progressions. Now let me first tell you that when it comes to progressions, there are two types of progressions which we shall be learning. We have arithmetic progressions and geometric progressions. In brief, we call them AP and GP. Now from the exam point of view, if you look at the type of questions which are coming in the exam, well, we can expect at least 3 to 4 questions from these two chapters, AP and GP. Progressions has been divided into 2 sessions. Today we shall be focusing on series, sequence and arithmetic progressions or AP, and on the next day we shall be focusing on geometric progressions or GP. Today we shall also be learning about different type of progressions. What is a sequence? What is a series? What is an infinite series? And when it comes to arithmetic progressions, two very important parts, that is to find out the nth term in a progression and to find out the sum of a series of arithmetic progressions, AP series. Plus we shall take up basics of GP and what is the exact difference between AP and GP. Plus we will do some recap on what we have done on the last day. That is, we discussed about permutations and combinations. Today we shall do a recap and I shall be answering many of the queries. Plus I shall be solving some more examples from the study material from the question papers. Right. So let's get going and go to the first concept. Friends, we shall learn new terms today. Like in the last session, we learned about factorial and we discussed about what is permutation, where the order was relevant. In case of combination, we saw the order was not relevant. So today, when we talk of sequence and series, first is what is sequence? So the first term which you need to know is what is sequence? Sequence of numbers means, say I write 1, 3, 5, 7, 9 and so on. So I can say it is a sequence of numbers, that is, it is a set of numbers. It is a set. A set of numbers starting with 1, and if you see, I have included the odd numbers 1, 3, 5, 7, 9, 11 and so on. So it has a specific order. The numbers are not haphazard, but they are having a specific order. And what is the order? You can see that 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. So it obeys a particular order. So sequence is a set of numbers which have a particular order. Now, if you look at these numbers, 1, 3, 5, 7, these numbers are ultimately making up this sequence. These numbers are known as terms. So these numbers are called terms, T-E-R-M-S, terms. These are the different terms which are included in this sequence, in this series. Now we come to what is, so we saw what is sequence. Sequence is a series, is a set of numbers in a specific order. Then we saw what are the terms. Terms are the individual numbers which make up this particular series. If I write another series, say another sequence, let it be say 1, 2, 4, 6, 10, 14, 20. This could be another series, another sequence. So here 2, 4, 6, 10, 14, 20 and so on. These numbers constitute the terms. These numbers are the terms, right? And when we talk of sequence, there is something which is called arithmetic sequence. Arithmetic sequence. What is an arithmetic sequence? Please see in this case 1, 2, 4, 6, 10, 14. Let us look at the difference between the terms. 2 minus 1 is 1. 4 minus 2 is 2. 6 minus 4 is again 2. 10 minus 6 is 4. 14 minus 10 is 4. 20 minus 14 is 6. That means the difference between two successive numbers. So let us see the differences. The difference, the first one is 1, then again 2, then we have 2, then 4, 4, 6. That means the differences between the numbers in the sequence, are they same? Are they equal? No, they are not equal. So you can see 1, 2, 2, 4, 4, 6. The differences are changing. The differences are not constant. So arithmetic sequence is a series where the differences between the numbers will be constant. For example, if you see this particular series, 1, 3, 5, 7, 9. Difference between every two digit, 3 and 1. 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. That means the difference between the numbers, the successive numbers in this sequence are constant. So in case of arithmetic sequence, we say that the difference D has to be a constant. In this case, the constant is 2. Similarly, if I write a particular sequence, so you can see 1, 2, 4, 6, 10, 14, 12, 20. Is this a sequence? Yes, it's a sequence because it is a set of numbers. But is it an arithmetic sequence? Shall we call it an arithmetic sequence? No. Why? Because the difference between two successive numbers in this sequence is not constant. The difference is changing. We have 1, 1, 1, 2, 2, then we have 4, 4, 6. It is changing. Let me give another example of what is sequence and let us see whether it is an arithmetic sequence. 1, 3, 7, 13, 20, 29. 1, 3, 7, 13, 20, 29. Let us see whether it's a sequence. Yes, it's a sequence because it is a set of numbers. It has an increasing order. The order is increasing. Fine. It is a sequence. 7 is greater than 3. 13 is greater than 7. 20 is greater than 13. 29 is greater than 20. So it is increasing. Right? Fine. So it is a sequence. It is a sequence. But will it be an arithmetic sequence? That is the question. Is this going to be an arithmetic sequence also? Let us see the differences between successive terms. 3 minus 1. Okay, I write the difference here. 2. 7 minus 3. 4. 13 minus 7 is 6. 20 minus 13 is 7. 29 minus 20 is 9. So dear friends, you can see that the difference between the numbers is not constant. It is changing. 2, 4, 6, 7, 9. It is changing. So between any two numbers, 13 and 7, it is 6. 20 and 13, it is 7. So it is not constant. So this series or this sequence, if you see the sequence, is not an arithmetic sequence because the differences are not constant. And friends, there is one more term which we need to know at this point, that is, which is called common difference. Common difference. Okay. So what do you mean by common difference? Common difference means 3 minus 1. The difference is 2. 7 minus 3. So the common difference between the numbers, the differences between every two successive numbers is called common difference. Like here you can see 3 minus 1 is 2. So the common difference, sometimes we write as CD, common difference. This is 2 here. Okay? So this particular sequence, 1, 3, 7, 13, 20 and 9, 29, this is a sequence, no doubt about it, but it cannot be called an arithmetic sequence because the difference, that is the common difference. What is common difference? The difference between every two successive numbers is not constant. So we talked about what is sequence. Sequence is a set of numbers which obeys a specific order. We saw some example of sequences. Then we noted that arithmetic sequence is a sequence where the difference between every two number is constant. So 1, 3, 5, 7 and 9 is an example of arithmetic sequence. But when you talk of 1, 3, 7, 13, 20 and 29, it is not an arithmetic sequence because it does not. The difference is not the same. So that means a sequence is an ordered collection. It is a collection of numbers. It is a set of numbers which obeys certain rule, certain order. So that is called a sequence. Okay. Let us see some more sequences. Okay. I'll rub it up and let's see some more sequence. And let us analyze each of them. Okay. So the first sequence. Okay. 28. 2. 25. 27. Okay. What is your idea of this? It is a collection of numbers, but you can see it does not obey any particular order. 28, then suddenly it comes down to 2, then it increases to 25, a big jump, then again 27. So order is a question mark. It may not have any order. So it cannot be called a sequence. Let us see the next one. 2. So this is number 1, number 2 now. 2, 7, 11. 2, 7, 11. 19. 31. 51. 2, 7, 11. 19. 31, 51. Is it a sequence? It seems to be a sequence because it obeys an order and the order is increasing. The numbers are increasing. Okay? Of course, let us see the difference now. The common difference. 7 minus 2 is 5. 11 minus 7 is 6. 19 minus 11 is 8. 31 minus 19 is 12. 51 minus 31 is 20. So dear friends, you can see the common difference. What is common difference? Common difference is the difference between two successive numbers in this sequence. Right? So 7 minus 2 is 5. 11 minus 7 is 6. 19 minus 11 is 8. 31 minus 19 is 12. And 51 minus 31 is 20. So we can see that the differences are 5, 6, 8, 12 and 20. So the differences show that they are increasing. Okay? So it has a particular order. Therefore, it can be called a sequence. But is this sequence an arithmetic sequence? Can you call it an arithmetic sequence? No, because the differences are not constant. Let us see the next one. Very simple, 1, 2, 3, 4, 5, 6 and so on. Is it a sequence? Yes, because the numbers are increasing. Fine. Is it an arithmetic sequence? Let us see. So again we calculate the common difference. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1. Very good. So this is a sequence, plus it is also an arithmetic sequence. Why? Because the difference between two successive digits is constant. That means the common difference is the same. It is 1 in this particular case. Okay, let's see the next one. So I hope you can see the difference between what is a sequence and what is an arithmetic sequence. Let us see the next one, number 4. 20, 18, 16, 14, 12, 10 and so on. Is this a sequence? Yes, it seems to be an order of numbers. It is a sequence because it's a set of numbers and there is an order. You can see there is an order in this particular sequence. The order is that it is decreasing. Instead of increasing, here it was increasing. 1, 2, 3, 4, 5, 6, increasing order. 2, 7, 11, 19, 31, 51, increasing. So they were increasing in this way. 1, 2, 3, 4, 5, 6, increasing. But 20, 18, 16, 14, 12, 10, this is decreasing. Fine. So it is a sequence because it obeys a decreasing trend. You can find some balance in the sense that it is coming down. You can find some trend. See, we use the word trend. T-R-E-N-D. We always ask, what is trending on the internet? What is viral? Which video is trending now? Okay, what dress is trending? What is the in thing? Okay, similarly, trending means the pattern. Trending means the nature. Here you can see the trend is, it is decreasing trend. Now let us see whether this sequence is an arithmetic sequence. So let us find the common difference. 20 minus 18. The difference is minus 2. Minus 2. It is decreasing. Okay. 18 minus 16. Again minus 2. 16 minus 14. Minus 2. 14 minus 12. Minus 2. And 12, if you see, 20 minus 18, sorry. It's a difference. Minus 2. 12 minus 10. It is again minus 2. In other words, 18 minus 20 is minus 2, 16 minus 18 is minus 2, 14 minus 16 is minus 2, 12 minus 14 is minus 2, 10 minus 12 is minus 2. So, second term minus first term is minus 2. In this case, the second term minus first term was 1, positive. So, it was increasing. Here, the difference of the terms, 18 minus 20, 16 minus 18, 14 minus 16, 12 minus 14. This gives you a negative trend. So it is minus 2 everywhere. So the common difference is minus 2. That means this is a sequence, number 1. Secondly, it is an arithmetic sequence where the common difference is minus 2. In case of 1, 2, 3, 4, 5, 6, the common difference was plus 1. It was increasing. In this case, 18 minus 20, 16 minus 18, this gives you minus 2, which means it is showing a decreasing trend. But it is an arithmetic sequence because the common difference is constant and the common difference is minus 2. I hope you have understood this. These are very basic ideas. And now we move on to see what is another type of series. Let's look at another series. Now, just to have a brief understanding, you could understand what is an arithmetic progression, but let us see what is a geometric progression also, just to have an idea. Now, I am giving two scenarios. The first scenario is investment. Say, now in the last classes, I think you remember we did the time value of money. Now when we discussed about the time value of money, we discussed a number of questions on investments and returns. Now if I tell you that you have an investment where year 1, 2, 3, 4 and 5, in the first year you have a return of say 5%, second year you have 7%, third year 9%, fourth year 11%, fifth year 13%. 5, 7, 9, 11, 13. It's an investment. Is it a sequence? Yes, it is a sequence. Why it is a sequence? Because it is a set of numbers 5, 7, 9, 11, 13 and it is showing an order. There's a particular order in these numbers 5, 7, 9, 11 and 13. We have an order. Order means what? A pattern. So order, when we talk of the word order, please note it means trend. It means pattern. Okay? So there is a pattern. You can predict. So 5, 7, 9, 11, 13, you can predict that the next year it will be 15. So you can predict, you can forecast. Okay? So this is definitely a sequence. Is it an arithmetic sequence? Yes, because if you look at 7 minus 5, second term minus first term, it is 2. 9 minus 7, again 2. 11 minus 9 is 2. 13 minus 11 is 2. So the differences between two successive numbers is constant, it is 2. So definitely it is an arithmetic sequence. Now, say in the first year, this is an investment, fine. In the first year, you got a return, so this is okay. Say you got a return of say 3%. Next year you got a return of 6%. Third year you got a return of 12%. Fourth year 24%. And fifth year is 48%. 3, 6, 12, 24, 48. Okay? So please note, the first series we had 5, 7, 9, 11 and 13. Now, this is the first investment. Say there is another investment scheme, right? Where you are getting 3% in the first year, 6% in the second year, 12% in the third year, 24% in fourth year and 48%, a whopping 48% in the fifth year. Is this a sequence? What do you think? It is an orderly set of numbers. So it is a sequence. It is a sequence. Now, do you see some order in this? Do you see a trend in this? Can you identify the pattern in this? I'm sure you can. It is increasing, number one. And number two is 3. Here we had 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 9 is 2. So here we were subtracting, right? So I'll use the subtraction sign. Okay, so everywhere we were doing subtraction. But here if you see, if you subtract, what do you get? 6 minus 3, you get 3. 12 minus 6 is 6. 24 minus 12 is 12. 48 minus 24 is 24. So here we find, dear friends, that the differences are increasing. Okay? And if you just see the sequence here, 3 into 2 gives you 6. So if you divide, 6 divided by 2 gives you 3. 12 divided by 2 gives you 6. 24 divided by 2 gives you 12. And 48 divided by 2 gives you 24. That means here the series is increasing, no doubt, but there's a difference. It is becoming double. 3 into 2 is 6. 6 into 2 is 12, 12 into 2 is 24, 24 into 2 is 48. So dear friends, I hope you can see the difference between these two numbers. Both are a set of numbers. 5, 7, 9, 11 and 13 is a set of number. 3, 6, 12, 24, 48. This is also a set of numbers, but there's a difference between them. What is the difference? In the first case, 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 9 is 2. Which means that the common difference is constant and it is equal to 2. Fine. But in the second case, here we are not subtracting, here we are dividing. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. So the second series, the second sequence is basically something where you are multiplying by 2. 3 into 2 gives you 6. 6 into 2 gives you 12. 12 into 2 gives you 24. This first pattern which you see is an arithmetic progression, and the second one is a geometric progression. Because here the increase is taking place in a geometric way, we are multiplying. There's a common ratio. In the first case, we call it a common difference. But in the second case, the first case is a case of common difference. Okay? But the second case, 3, 6, 12, 24 and 48, this is a case of common ratio. Both are of course increasing. Both are increasing. In the first case, 5, 7, 9, 11, 13, it is increasing. It is a linear relation. But the difference between two successive terms is constant. So the first one is an example of an arithmetic sequence, and the second one is an example of a geometric sequence. So this, dear friends, is the essential difference between AP and GP, arithmetic progression and geometric progression. In case of arithmetic progression, we find out the common difference by subtracting any term, say 7. So what we do is third term minus second term. T3 minus T2, 9 minus 7, we get 2. 13 minus 11, we get 2. Here, we don't subtract, we divide. 12 by 6 is 2. 24 by 12 is 2. 48 by 24 is again 2. So here, the common ratio, in the second case, the common ratio is constant and it is 2. So this is a geometric progression, a geometric type of sequence. Now, if these two are the returns, which one would you prefer? Which is better you feel? The first one or the second one? Now in the second one, the returns are increasing exponentially. Exponentially, we use the term exponentially. That means it is increasing at a rapid rate. Here it is more or less linear. Okay, just a 2% gap. But here you see the gap. First year to second year, 3%. Second year to third year, 6%. Third year to fourth year, 12%. It is increasing in a much more rapid manner, in a much more faster manner. Therefore, this is known as a geometric progression because you multiply 3 into 2 is 6, 6 into 2 is 12, and in the first case, it is an arithmetic progression. So this is the difference. Which one is suitable? Which one is better for you? Well, since you have learned time value of money, definitely the second one seems to be more lucrative, but in finance you will learn later, higher the return, higher is the risk also. But from a layman's perspective, if I am a layman with no idea of risk and return, if somebody tells me there are two investment options, option 1 gives you 5%, 7%, 9%, 11 and 13, and option 2 gives me 3, 6, 12, 24, 48, I will choose the second one. Fine. Right. So this is an example of the difference between AP and GP. Now I take another case. Okay. I will not call it investment anymore, but I will look at something different and something which is now creating a huge impact on the entire world, and I'm talking about COVID-19. Now, if I say that in a country C1, there are two countries, C1 and C2. Okay? Two countries, C1 and C2. Fine. C1 and C2. And this is month 1, M1, month 2, month 3, month 4 and 5th month. Okay? The first month, second month, third, fourth and fifth. In country C1. Okay? The two countries we are taking, C1 and C2. Two different countries. C1, the spread of COVID virus in the first month was say 10%. Okay? Percentage. Second month it became 13. Next it became say 16. I'll put it 16. Okay? Third month it became 16. Then it became 19, then 22%. So 10%, 13%, 16%, 19%, 22%. Is this a series? Do you feel it is a series? 10, 13, 16, 19, 22. Is it a sequence? Yes, it is a sequence. Because it is an orderly set of numbers, the numbers are showing an increasing trend. Plus, the second observation is 13 minus 10 gives us how much? 3. So I write 3 here. 16 minus 13 is 3. 19 minus 16 is 3. 22 minus 19 is 3. Okay. So this is an example of an arithmetic sequence with the common difference of 3. Now in country 2, let's see the condition. First month, the COVID-19 virus, I mean to say the number of affected people. So in the first country C1, 10% of the population got affected in the first month, 13% of the population got affected in the second month, 16% of the population got affected in the third month, 19% in the fourth month and 22% in the fifth month. This was the trend of the expanse of the COVID-19 virus, the number of people who contracted the coronavirus disease. Now, if you look at the second country, first month, only 4% of the population was infected. In the second month, only 8% was infected. In the third month, it is 16%. In the fourth month, 32%. And the fifth month, 64%. What is your opinion on this second? Which country has higher contraction of COVID-19? In which country is more dangerous? Which country is more risky? Which country has a greater number of population who have contracted COVID-19? Definitely second country. Even though they started with 4%, but see the sequence. 4, 8, 16, 32, 64. 4 twos are 8, 8 twos are 16, 16 twos are 32, and 32 into 2 gives you 64. So the first example was an AP. It's an arithmetic progression. It is increasing AP. The second case is a GP. It is increasing at a geometric rate, GP, because we find that in the first case, there is a common difference, 13 minus 10. 16 minus 13. But in the second case, we find there is something called common ratio because 4 into 2 gives you 8. 8 into 2 gives you 16. 16 into 2 gives you 32. So it is increasing at an exponential rate and we are multiplying 2 to get the next number. So in the second, both are progressions. Both are sequences. But the first one is an arithmetic one and the second is a geometric one. Which country is preferable? Which country is safer? Definitely first country. So you can see GP is not always good. When in case of investment, in the last example, we found out that second option seemed to be more lucrative. Second option seemed to be giving you more money. Your return was higher because the jump was going up like this. Steep curve. Arithmetic progression is a flat line, but a geometric will be steep. You are going up like this. In this case, 10, 13, 16, it is a flatter line, not high, flat. Not a steep one, flat. But 4, 8, 16, 32, 64, oh my God, it is going up. So it's steeper, a steeper curve. This is GP, this is AP. The first one is AP, the second one is GP, right? So now, let us see some more examples. I hope this is clear. So we have looked at what is sequence. We looked at what do you mean by terms. Then we saw the difference between what is an arithmetic sequence and arithmetic progression sort, and then we saw what is the essential meaning of a geometric progression. Okay, now let us see how to find out the nth term. Now some formula. You have to remember some formula. Right. So let us first note down a sequence. So it is an arithmetic sequence or arithmetic progression. You can say AP, arithmetic progression. 2, 5, 8, 11 and 14 and then so on. Okay. Now let us find out in this chapter, you know, you will be getting two types of problems. Either they will ask you in the exam to compute, to calculate the nth term in the series, or they will ask you to find the sum of the series. Okay? Now here one more point. Series, when we talk of the word series can be of two types. We have finite and we have infinite series. Right? Say for example a series like this. S is equal to say 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. Well, there are how many terms? 1, 2, 3, 4, 5. 5 terms. The first term is 5 and the difference between every two term is also 5. So the term 1 is 5 and it increases. The common difference is also 5. And there are 5 terms. Fine. This is a finite series. Example of a finite series. Now if I write that another series, I'm writing 2, 4, 6, 8 till 50 terms. Okay? 2, 4, 6, 8, 10, 12, 14 till 50 terms. This is a series. Yes. It's a sequence. Yes. Is it finite or infinite? It is finite because the number of terms is 50. So I know 2, 4, 6, 8, 10, 12, 14, 16, 18. I go on till 50 terms. It is limited to 50. So it is finite. Finite means you know something which can be counted. There is a limit. Okay, 50. The limit is 50 in this case. But if I say that a series, right, say if I say that the series is a series of the natural numbers starting with 1. So it will be 1, 2, 3, it will go on and on. It is going to go on and on. There is no end to it. So this can be an example of an infinite series. So what is a finite series? A finite series means a progression or a sequence where the number of terms can be counted. The number of terms are limited. It can be 50, 100, 10 lakhs, 20 crore, whatever. But the limit, there's a limit. But if in case of a series, there is no limit, it goes on and on. Like we discussed in the time value of money chapter, you may remember we discussed about perpetuity. Perpetual, it goes on and on, no stopping. Infinite, you know infinity. We always write infinity like this. Infinity goes on and on. Because the concept of infinity you will also require when we discuss differential calculus and integral calculus, right? So, infinity. If a series does not stop, it goes on and on and on. Infinite series. Because you cannot count, you cannot limit, you cannot compute, it goes on and on. So, infinite. And finite is something which can be counted, there's a boundary, there's a limit, there's a ceiling, and it can be computed that way. Right. Fine. Now let us see the formula for finding out what is the nth term. Okay. So nth term and sum. So we directly come to the formula. So we have looked at what is sequence. We saw what is the basic difference, what are the different terms of a sequence. Right? We saw the concept of common difference, the difference between second term and first term, the difference between fourth term and third term, the difference between 10th term and 9th term. This is called the common difference. And we also saw that in case of an arithmetic progression or arithmetic sequence, so to say, the difference between the two numbers, the two successive terms will be constant. And it is called common difference, CD. Common difference. In this case, 2, 5, 8, 11, 14. It is an AP, arithmetic progression, and the common difference is 3, because 5 minus 2 is 3, 8 minus 5 is 3, 11 minus 8 is 3, 14 minus 11 is also 3. So it is having a common difference of 3. I hope it's clear. We are proceeding further, and now we saw the difference of series. There are two types of series, finite and infinite. For example, 2, 4, 6, 8, 10 till 50 terms. It is an example of a finite series. If I say that a series comprising of, say, I write it here, say an example of finite series again. Now, if I say that series S is equal to multiples of 8, okay, from 8 till 8 million. I have to write the series of the multiples of 8, right from 8 till 8 million. So 8, 16, 24, 32, 40, 48, 56, 64, so on. It goes till 8 million. Is it a series? Yes. It's a sequence? Yes. Do you see some order? Yes. It increases. Is it an arithmetic series? No. Why? Because here what we see is multiple. Right? Is it a geometric series? 8 ones are a multiple means 8 ones are 8 to the 16. 8 3s are 24, 8 4s are 32. Yes. Common difference is also 8 if you see. Multiple. So it seems that it has the properties of little bit of AP as well as GP too. The common difference, if you see here, is 8, 16, 24, 32. In this way it is increasing. So we are multiplying, if you see, 8, 16, 24, 32. Here what is happening? It seems that 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32. But is it a GP? Some people get confused here. Is it a GP? No. Because the common difference is 8. But the common ratio is not fixed. 16 by 8 is 2. But 24 by 16 is not 2. So some people think, oh, 8, 16, 24, 32, it seems like a GP. No. GP means the common ratio. GP, that is geometric progression, means the common ratio will be fixed. This is a series which has the multiples of 8 from 8 till 8 million. This is an arithmetic series because the common difference will be 8. It is constant. So this is an example of a finite series, right? In finite series, I have already taken examples. Now we come to the formula. You have to remember only how many? 3, 4, 5 formula. This is otherwise a very easy chapter, and the numericals, as I said, will be at least 2, and at the most you can expect 4 numericals, maybe 2 from arithmetic progression, 2 from geometric progression, and 3 is more. I mean, I think we normally get 3 questions, but you could get up to 4 questions. Otherwise, an important chapter, but not a very difficult chapter because it is based on formula. It is not based on concept. Permutation combination is based on concept. Time value of money, I say, is based both on concept as well as on formula, because you have to learn so many formula. Concept wise, you learned about time value of money, you learned about future value, and so many formula, right? You remember what we did: annuity regular, annuity immediate, right? Then present value. So time value of money is an example of both formula and concept. This chapter is based on formulas, more on formulas, less on concept. So we look at 2 formulas. First one, if you have a series, arithmetic progression, arithmetic sequence, right? So the first term is A. The second term is A plus D. Okay? The third term, T3, is A plus 2D. The fourth term is A plus 3D. In this way, the nth term, Tn, is equal to A plus n minus 1 into D. Dear friends, please note down this formula. Tn is equal to A plus n minus 1 into D. Very important. Okay? Nth term, Tn, is equal to A. A is the first term. A is the first term. A plus n minus 1. N is the number of terms. Into D. What is D? D is the common difference. So in this case, 2, 5, 8, 11 and 14. Okay? The first term is 2. Right? So T1, in this case, T1 is 2. Term 1 is 2. What is the common difference? D. D is equal to 3. 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. So if I ask you, in this series, 2, 5, 8, 11, 14, etc. is going on, can you find out the 10th term? Can you find out the 10th term in this series? Yes, we can. We can. And here the formula Tn, A plus n minus 1D. This formula will help us. We have to use this formula to find out the 10th term. So T10, that is 10th term, will be equal to A. A is 2. So I write 2 here. Plus n minus 1. Here n is 10. 10th term. So n is 10. So I write 10 minus 1. D is difference. D is difference. D is 3. So 10 minus 1 into 3. That means 2 plus 10 minus 1 is 9. So 9 into 3. 2 plus 27, that is 29. So the 10th term will be 29. So this is how we find out. So this formula, nth term, Tn is equal to A plus n minus 1 into D. Please note it in your copybook, also in your mind, because this is a formula which you will always require for calculation of nth term, and many such numericals are going to come in the exam. Today I shall be taking up many of the examples from our study material, plus we will solve the problems which has come on this chapter AP Arithmetic Progression in the CA MTP, that is Model Test Paper, May 2020. Okay. So we have seen the first example. Fine. Now I write some series arithmetic sequence and let us see whether we can find out. I am keeping the formula as it is. I'll just rub the upper part and let us write some series. Okay, arithmetic series. Fine. This formula is very useful, so it's there. Say you have to find out the common difference. Okay, I write some series. S1, series 1. -3, -6, -9, -12, and so on. You have to find out difference, common difference. S2, series 2. 1.1, 2.2. Just rub it. 1.1, then I have 2.2. 2.2, then I have 3.3, 4.4, and so on. You have to find the difference. Series 3, 41, 32, 23, 14, 5, and so on. What is the difference? Series 4, 1, 2, 4, 8, 16, 32. Fine. Let us see the first one. Right? I hope you can see clearly. First one is S1, series S1, and the numbers are -3, -6, -9, -12. Is this an arithmetic sequence? First of all, is it a sequence? Yes. Why? It is a set of numbers. Yes, you agree? It is a set of numbers. Second, do you see any trend? See, I wrote about 3 words. Trend, pattern, and order. Right? So writing once again, don't forget this. Please don't forget. Trend, order, and pattern. Okay? In short, I will put it like this. It will help you to memorize. You just remember the word top. T-O-P. T for trend, O for order, P for pattern. Top. Just remember top. You should go to the top. Should be at the top. Be a rank holder. Right? So top of success. So T-O-P. T for trend, O for order, P for pattern. Do you find any top here? Top. Any trend, any order, any pattern? Well, -3, -6, -9, -12, yes, there is a distinct order, a distinct trend, and you see it is decreasing. -3, then -6 is decreasing, -9. So here, the common difference is how much? It is decreasing by how much? It is decreasing by 3. So the common difference is -3, right? So I write common difference -3. Fine. The next one, 1.1, 2.2, 3.3, 4.4. Is it a sequence? Yes. Is it an arithmetic sequence? Okay, let me see. Is it a sequence? Yes, because it is increasing. 1.1, 2.2, 3.3, 4.4. There is a pattern, there is an order, there is a trend. Fine. So, is the difference 2.2 minus 1.1 is how much? 1.1. 3.3 minus 2.2 is how much? 1.1. 4.4 minus 3.3 is how much? Again 1.1. So, the common difference, the difference is same. Okay? The difference is uniform. The difference is constant. Therefore, this is also an arithmetic sequence, and here the common difference is 1.1. Okay? I hope you can see the different types of series, and you can see that the common difference of course, can be a whole number, a positive whole number. It can be a negative whole number. It can be anything. It can be a fraction also. It can be positive as well as negative. As you can see here, we have decimal 1.1. Okay. Now let us see the third one, S3. 41, 32, 23, 14, 5. Please. Is it a sequence? Let me see. Yeah, it looks like a sequence. There is a top, T-O-P, top. Okay? There's a trend. There's an order. There's a pattern. Why? Because it's going down again. 41, okay, then 32, then 23, then 14, then 5. There is a distinct order. There is a direction. It's coming down. Okay. Oh, it's a sequence. Fine. Now, is it an arithmetic sequence? Let me check. 32 minus 41. How much? Oh, minus 9. 23 minus 32. How much? Again, minus 9. 14 minus 23 is how much? Minus 9. 5 minus 14 is how much? Again, minus 9. Oh, fine. So, I've got it. S3 is a sequence, no doubt about it, but it is also an arithmetic sequence because the difference between two successive terms is constant and B is minus 9. Right? The last one, S4. 1, 2, 4, 8, 16, 32. Oh, let's see. Is it a sequence? Yeah, it's a sequence. Why is it a sequence? Because it is increasing. Right? I told you the short form is top. Okay? Trend, order, pattern. Do you see any top? Yes, there is a top. It's increasing. 1, 2, 4, 8, 16. Great. Very good. Excellent. Kudos. But the question is it an arithmetic sequence? Is it an arithmetic sequence? Let me see the common difference. 2 minus 1 is 1. 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. Oh my God. That means the difference is not constant. The difference is increasing. So this is not an arithmetic sequence. So here it's not an arithmetic sequence. Right? So we saw 4 examples, dear friends, of sequences where 3 of them are arithmetic sequence. In the first case, we found that the common difference is minus 3. In the second case, we saw that the common difference is 1.1. Right? The third case, we found the common difference again is negative, minus 9. And in the fourth case, we saw that it is not at all an arithmetic sequence. Right. Let's see another one. I just rub this up and let us see another sequence. "74, 67, 60, 53. What will be this term? Let us find out. Okay? So you are having 74, 67, 60 and 53. Okay? So you have to find the next term. So this is the first term. So I can write A equal to 74. A equal to 74. Let us see the difference. First of all, does it look like a sequence? Does it look like a sequence? Check. Okay, 74, 67, 60, 53. Does it look like a sequence? Let me think. Yes. Yeah, it's a sequence. Because there is a top. There is a trend. It is decreasing. 74, 67, it's coming down. Is it an arithmetic sequence? Let me see. 67 minus 74. Okay, it's minus 7. Oh, minus 7. 60 minus 67. Minus 7. 53 minus 60. Again, minus 7. Fine. So, from here I can see the difference is minus 7. And A I know is 74. And I have to find out this one. That means first term, second term, third term, fourth term and fifth term, I have to find out T5. That means n is equal to 5. Simple. I use this formula and I write here, in place of A, I would write what? 74. So I write 74 here, plus n is 5. So 5 minus 1 into D, and D is minus 7. So I write minus 7. So this becomes 74 plus 5 minus 1 is 4. 4 into minus 7 is minus 28. So 74 plus of minus 28. So 74 minus 28. So it comes to 46. Right? Please check. So I am using this formula. So I know this one, the next one is 46. Of course, 53 minus 7 also you can find. But I am using the formula. So if they ask you that instead of the fifth term, if they ask you the 20th term, same thing. Fine. So this is A plus n minus 1 into D. Now we look at the formula for this sum. Okay? Fine. Please note down. Let me check. Okay, let me do one more problem. Then we will go into sum. The formula is there for you and the full form of top is also written. Let us check this problem. You have to find out the 10th term. Series is 1, 7, 13, 19. Okay? I'll take this one. Let me check this one. Yes. 1, 7, 13, 19 and so on. You have to find out the 10th term. The 10th term. 10th term means here A equal to 1. It starts with 1. 1, 7, 13, 19. Okay, 1, 7, 13, 19. Is it a sequence? Yes, it's a sequence. Why? Because there is a top, there is a trend, there is an order, there is a pattern, it increases. Fine. Do you have a common difference here? Yes. The common difference is 6. 7 minus 1 is 6. 13 minus 7 is 6. 19 minus 13 is 6. So I write D equal to 6. Fine. I have to find the 10th term. That means T10. That means N is equal to 10. So I use the formula here. And what I do is, I write term T10 is equal to A is 1, 1 plus 10 minus 1, 10 minus 1 into D. D is how much? 6. So this is 1 plus 10 minus 1 is 9, 9 into 6 is 54, so it gives me 55. Okay, so I am able to find out the 10th term. So this is a type of problem which you get very frequently. Right? Now let us look at some more problems and let's see this one. Okay. I'll give you another sequence, see if you can do it. Okay. Here what they have given is the next problem. The first term is 3. So A is given 3 and the common difference is 21. Okay? The common difference is 21. You have to find out the 10th term. Okay? So A is given, you have to find out the 10th term. So same formula, T10 is equal to A plus N minus 1 into D. A here is 3 plus N minus 1, that is 10 minus 1, that is 9. 9 into D is 21. Okay? So this is 3 plus 21 into 9, 21 into 9, 189, so it is 192. So this is also another type of problem which comes where the first term is given and the common difference is also given. You need to find out what will be the nth term. Okay. Right. Let's see this one. Another problem. So fairly easy, I think. I think this chapter will not give you trouble like the chapter on permutation combinations. Yes, some of you are confused. You were confused about the difference of permutation combination, right? But you remember the rule, golden rule, like here I was talking about the golden rule of top, trend, order and pattern. In case of permutations and combinations, again there was something called order. Why? Because if the order of the terms ABC, CBA, BCA, if the order is significant, if the order is relevant, then it becomes permutation. If the order is not relevant, it becomes combination. Normally in case of problems, in the case of progressions, for example, right? In progressions, you will be getting two types of terms, two types of problems. First is they ask you to find out the nth term, and sometimes they ask you to find out the sum. Right. Let's do one more on nth term. Now the question is, there is a series 4, 7, 10, 13 and so on. Now there is a particular term 301 in this series. You have to find out which term. Right? So the series is given 4, 7, 10, 13. Please note it is like an arithmetic progression because it is increasing, progressing in an arithmetic way because 7 minus 4 is 3, 10 minus 7 is 3, 13 minus 10 is 3. That is the common difference is 3. And the first term A is 4. You know A, you know D, you also know there is a term, let's call it the nth term. So Tn is 301, you know this. You have to find out the value of n. So how do we do it? So I can write like this formula, okay? So what I'll do is I'll use this formula and I will write that you have to find out the nth term. So I will write that A plus n minus 1 into D is 301. We don't know the value of n, but we know the value of A, we know the value of D also. A is 4, so 4 plus n minus 1 into D. D is 3. This is 301. So if you simplify, it becomes how much? 4 plus 3n minus 3 equal to 301. That means 4 minus 3 is 1. So 3n equal to 300. That is n is equal to 100. N is equal to 100. That means in the 100th term, 301 will come. This is the 100th term. The 100th term in this series will be 301. Okay? I hope this is quite easy for you. The one formula you need to remember is simple, and that is you need to remember A plus n minus 1 into D. Okay? Now we go to the second formula and we look at the sum. What is the sum of the sequence? Okay. Now we look at the second formula. I rub out this part. You know what is trend, order and pattern. You have noted this. You have noted the first formula. Now we go to the summation formula. Okay? The sum of a series. The sum of a series. The sum of a series. Let S be a series of n terms, Sn. So the sum is equal to, please note, n by 2 within bracket 2 into A plus n minus 1 into D. So this again, I would request you to remember. I am keeping it in a box. Okay, so that it's an important formula. Very important formula for you. So n by 2 divided into 2a multiplied by 2a plus n minus 1 into d. This is the sum. So we have two formula to find out the nth term we have Tn equal to a plus n minus 1 into d, where a is the first term and d you know is what? D is the common difference. This is the example, this is the second formula, and this formula is used to find out the sum of the series. That means if there is a series like this, say 1 plus 4 plus 7 plus 10 plus 13 plus so on, it will say 20 terms. So what will be the sum of this? Okay. So the sum will be according to this formula. So let us do a small problem, or let's take a simple question here. Right. So this arithmetic progression is quite an easy stuff. You need to remember just the two formula, and not much of concept is required. Once you remember the formula, you can easily solve. Right. There's a question here. It came in the exam. This is page 6.4 of the study material. Page 6.4 of the study material. Okay. 6.4. Please come to 6.4. Example is 1. I'll take the examples quickly. There's an AP given 8, 5, 2, minus 1 and so on. You have to find out the seventh term. So you have to find out T7. Okay. So the series is given to you and it is starting with the first term is 8. You have 8, 5, 2, minus 1 and minus 4 and so on. You have to find the seventh term, T7. Fine. Not a difficulty. We know the formula A plus n minus 1 into d. So T7 will be equal to A plus n is 7 here. So n is 7. So it will be 6 minus 1 into d. Now A is, we know A is 8. The first term is 8. And the difference, the common difference is 5 minus 8. Minus 3. Be very careful. It's minus 3. 2 minus 5 is minus 3. So it is minus 3. So therefore, A plus 6 minus 1 into D. A is 8. So I write 8 here. Plus 6 minus 1 is 5. And D is minus 3. So 5 into minus 3. So it becomes 8 plus minus 15. So this is minus 7. Let's check. Seventh term. So this is 6. No. Sixth term. This is will be 6. Minus 18. Yeah, this is 7 because we are doing the seventh term. Yeah, term 7. So A plus 7 minus 1 into D. 8 plus. So it becomes A is 8. We take, this will be 7 minus 1 is 6 into minus 3. So it is 8 plus minus 18. That is minus 10. Minus 10. Okay. So here we are taking A plus n minus 1 into D, where n is 7. A is 8 and the common difference D is equal to minus 3. So this is 6.4. Okay. Let us take the next one. Yeah, we need to remember some more formula here and then we will do the exercise questions. Because many of the examples are given and examples are already solved. So I'll focus more on the exercises. Okay. Now some more formula. So this is okay. Tn we know is A plus n minus 1 into D. This also we saw. So formula 1, formula 2. Now here I write the formulas. Now there is another formula which you need to remember, a very simple formula. And that is sum of the first n odd numbers. Odd number sum. That means, odd number is what? 1, 3, 5, 7. So, 1 plus 3 plus 5 plus 7 and so on till n. What is the sum of this? Very simple. S equal to n square. So, please remember this formula also. So, we saw sum of a normal series, nth term of an arithmetic progression. This sum is also for arithmetic series. Term n. Tn you can find out. Odd number, right? 1, 3, 5, 7 like this, the odd number till n. you can find out the formula S is equal to n square, right? So if n is 10, for example, so 1 plus 3 plus 5 plus 7 till 10. So you can find out the formula from the formula 10 square. Next is the fourth formula which you need to remember is 1 square plus 2 square plus 3 square. What is the sum? 1 square plus 2 square plus 3 square plus 4 square plus so on plus n square. Okay, so this formula you need to remember again. It is n into n plus 1 into 2n plus 1 by 6. N into n plus 1 into 2n plus 1 by 6. So you have to remember this one, this formula 1, 2, 3, 4 and the last one. 5 formula I told you. You need to remember 5 formula for this chapter AP. Okay, and for GP another 2 or 3. So just remembering 8 of them. And first one we did was a plus n minus 1 into d, which gives you the nth term. This already we have done. Summation we will do odd number, a 1 plus 3 plus 5 plus 7 till n. If you need to find out the sum of such a series, the formula is S is equal to n square. If you have to find out the sum of the square of the first n natural numbers, 1 square plus 2 square plus 3 square plus 4 square plus 5 square till n square, the formula is n into n plus 1 into 2n plus 1 by 6. Okay, so formula number 1, formula 2, formula 3, formula 4, and now the fifth formula, that is what happens if you have to find out the sum of the series 1 cube plus 2 cube plus 3 cube. So first n, the sum of 1 cube plus 2 cube plus 3 cube and so on, it will be n into n plus 1 by 2 whole square. N into n plus 1 by 2 whole square. So please remember this as well. This is the last formula. N into n plus 1 by 2 whole square. So once again, I am repeating the formula. The term n, nth term of an arithmetic progression, a plus n minus 1 into d, where a is the first term and d is the common difference, n is the number of terms. Then we saw sum formula, the summation. So 1 plus 3 plus 5 plus 7 plus so on. The sum is n by 2, where n is the number of terms. 2 into the first term, 2a, plus n minus 1 into d, where d is the common difference. Then we saw the sum of the odd numbers, 1 plus 3 plus 5 plus 7, that is equal to n square. Sum is equal to n square. The fourth we saw is the sum of the squares, 1 square plus 2 square plus 3 square plus 4 square and so on. N into n plus 1 into 2n plus 1 by 6. And the fifth formula is the sum of 1 cube plus 2 cube plus 3 cube plus 4 cube. It comes to n into n plus 1 by 2 whole square. Okay, so these are the 5 formula which you need to remember. Okay, now we'll take some questions from the exercise. Just a sec, let me go to the exercises. Yes. Okay, we go to exercise number 6a. Fine. We go to 6a, exercise number 6a, just rubbing this. I hope you have noted the formula, the 5 formula which you require to solve any type of problems on arithmetic progression. Okay. Right. So we have talked about series, right, sequence. We talked about finite series, infinite series. Then we discussed about what is a sequence. There is a trend, there is some order, there is some pattern. And then we discussed about the types of progression, AP, arithmetic progression, where there is the difference between two successive terms of the sequence will be the same, it will be constant. In that case, we call it an arithmetic progression, and where we see that there is no concept of common difference, but there is a concept of common ratio. Like we talked about 2, 4, 8, 16, 32. So here it's increasing, but the increase is at a geometric rate because 2 into 2 is 4, 4 into 2 is 8, 8 into 2 is 16 and so on. So here it's a GP, it's a geometric progression. Now let us see example 6a, and the number is 7. Okay, we'll take around a number of problems so that you're absolutely clear with this. So exercise 6a, number 7. The value of x, please open the question. The value of x such that 8x plus 4, 6x minus 2 and 2x plus 7 will form AP. So what is the value of x for which 8x plus 4, 6x minus 2 and 2x plus 7 will form an AP? AP is an arithmetic progression. So what is an AP? A progression where there is a common difference, and the common difference, that is the difference between two successive terms, is identical, is equal, is constant. Fine. So how to solve this? Right, let's see what can be done. What is the value of x such that these three terms will form what? Will form a sequence, an arithmetic progression. Now, if these three terms are forming an arithmetic progression, right, then we can write, if this is term 1, T1, and this is T2 and this is T3, right? So we know T2 minus T1 will be the common difference. T2 minus T1 is the difference. Similarly, T3 minus T2. T3 minus T2 will also be equal to the common difference, and the common difference will be the same. T will be constant. I hope you are able to follow. First term is given, second term is given, third term is given, and they are in an AP. You have to find out the value of x so that these numbers, these expressions will be in an arithmetic progression. So what we are doing, the first logic is second term minus first term is common difference. Again, third term minus second term is common difference. So we are going to equate them. That means T2 minus T1, let us do. So T2 minus T1 means 6x minus 2 minus 8x minus 4. T2 minus T1. This should be equal to T3 minus T2 because both are equal to D. So if I say that A is equal to B and B is equal to C, I will always say A is equal to C. So this is equal to this is equal to this. So T2 minus T1 has to be equal to this, right? So T3 minus T2 is how much? T3 is 2x plus 7 minus 6x minus or minus 2, that is 6x plus 2. So minus 6x plus 2. So let's see the simplification. 6x minus 8x is minus 2x. Minus 2 minus 4 is minus 6. On the right hand side we have 2x minus 6x, that is minus 4x, plus 7 plus 2, that is 9. So if you bring the 4x here, you will get 4x minus 2x is equal to 9 plus 6, that is 15. 4x minus 2x is 2x, so 2x is 15, which means x is equal to 15 by 12. So the answer is, for x equal to 15 by 12, right, these three terms, 8x plus 4, 6x minus 2 and 2x plus 7 will be in AP. Please see the solution. So we have used the simple formula of common difference, and T2 minus T1 is common difference, T3 minus T2 is also common difference. So T2 minus T1 has to be equal to T3 minus T2, and we have solved it out. So this is the first. Hope it's clear. And you could see that we arrived at x is equal to 15 by 2. Okay, now we take, this is a tricky one, little tricky one. Let's do this one. 6a number 11. Take an easy one first. 6a number 11, question number 11. 6a, question number 11. Okay, I go to the 11th term, 11th question. There is a progression given 1, 4, 7 and 10 and so on. You have to find the 20th term. What is the 20th term? 1, 4, 7, 10 is given. You need to find out the 20th term. Exercise 6a number 11. Please open that. We have seen the formula. Tn is equal to a plus n minus 1 into d. Here a is 1 because the series starts with 1 and d is the common difference. 4 minus 1, 3. 7 minus 4 is 3. 10 minus 7 is 3. So the difference is 3. And you have to find out the 20th term, that means n equal to 20. So putting these values, a equal to 1, b equal to 3 and n equal to 20. Putting these three numbers right in this equation, what do we get? We get T20. T20. So it is like IPL T20. So T20 is equal to A is 1 plus n minus 1. So it is 20 minus 1 into D, and D is how much? D is 3. So this is 1 plus 20 minus 1 is 19. 19 into 3. Okay? So 1 plus 19 into 3. 19 into 3 is 57. So it is 1 plus 57. That is 58. So the answer is 58. The 20th term is 58. This is 6a number 11. Okay. Now let us do number 10. Okay. This is a tricky one. Little bit. Not so easy. Little tricky. I'm rubbing this. We will do number 10. Okay. Exercise 6a. We are focusing on number 10. Okay. Number 10. Now please see the question. Exercise 6a number 10. The nth term of the series whose sum to n terms is 5n square plus 2n. Please see the question. We have to find out the nth term of the series whose sum is equal to 5n square plus 2n. 5n square plus 2n. So this is the sum. Okay. We don't know, of course, we don't know we have to find out the first term. We don't know the common difference. We have no clue. We only know that the sum of the n terms is 5n square plus 2n. This is 6a number 10. Okay, 6a number 10. We only know that the sum is 5n square plus 2n. The sum of the n terms is 5n square plus 2n. But we don't know the first term, nor do we know the common difference. So what to do? And the expression looks tricky. So use of some intelligence. Okay. So let us do one thing. This is a generic term, right? Sn means n. If n is 2, for example, then let's see what happens. So let's take, let n be 2. Okay, if n is 2, we know the formula, sum 2, that is, when n is 2, the formula, remember, was n by 2, 2a plus n minus 1 into d. This was the formula for the sum. Okay. So for n is equal to 2, what will happen? It will become 2 by 2, 2a plus 2 minus 1 into d. Please see carefully. This will be equal to this. If I put n equal to 2 here, I get 5 into 2 square plus 2 into 2. So this left hand side has to be equal to this, because the generic term is given Sn is equal to 5n square plus 2n. That means if you put the value of n 0, 1, 2, 3, whatever, you will get this. It's like a we call it a function. Function is given. Okay. So what happens if you simplify this? So 2 by 2 is 1. So you have 2a plus d, because 2 minus 1 is 1. So 2a plus d is equal to 5 into 2 square. 2 square is 4. 4 5s are 20 plus 4 is 24. So we get an equation. 2a plus d equal to 24, where a is the first term and d is the common difference. 2a plus d equal to 24. How did we find this? By putting n equal to 2. Now we will put n equal to 3 and see what happens. Okay, so I'm writing here. Let n equal to 3. Then the sum will become what? N by 2. So the sum will become 3 by 2. 2a plus 3 minus 1. 3 minus 1 into d. So this is equal to 3 by 2. 2a plus 3 minus 1 is 2. So 2d. So this is equal to 2 cancels out. So you have 3 into a plus d. And this 3a plus 3d is equal to 5 into 3 square, because here n is 3. So 5 into 3 square plus 2 into 3. 5 into 3 square is how much? 3 square is 9. 5 into 9 is 45 plus 2 into 3 is 6. So 45 and 6 is 51. So 51. So I write 3a plus 3d is 51. So 2a plus d is 24 and 3a plus 3d is 51. If you divide this equation by 3, you get a plus d equal to 17. So 3 and 51 means 17 into 3. So now you have the equation 2a plus d equal to 24 and a plus d equal to 17. So if you deduct them, you get, if you deduct this one, b, from a, equation a is 2a plus d is 24 and equation b is a plus d equal to 17. So if you deduct b from a, that means what am I doing? I am doing a minus b. Okay, what do you get? Just find out. What do you get? d and d cancels out. So you get 2a minus a. A is equal to 24 minus 17, that is 7. So you get a equal to 7. If a is 7, then d becomes how much? 7 into 2 is 14. D becomes 24 minus 14. So d becomes 10. D equal to 10. Right? So now you know the first term a is equal to 7 and d is equal to 10. You have to find out the nth term. Okay? So let me just rub up this part. So it's a little bit long question, long answer, so many steps, but once you get accustomed to it, it will take less time. But it's not a very easy question, you can see. Now what I do is, I have got a equal to 7 and b is equal to 10. So I put that in the equation. I have to find out the nth term. So Tn, if you know, is a plus n minus 1 into d. A is 7. So I write 7 plus n minus 1, I keep it like this, and d is 10. So it is 7 plus 10n minus 10. That is 10n minus 3. Because 7 minus 10 is minus 3. This is the answer. You have got the answer now, 10n minus 3. Please have a look at the answers, you will realize. So 6a number 10 we have done. I think it is clear. So the formula, it's like a function, the formula was given. What we did was we just put n equal to 2 and then we did n equal to 3 to get two equations from which we solved a and d. We got a equal to 7 and d equal to 10. A is the first term equal to 7 and d is the common difference. We got d equal to 10. We put those values again here in this formula to get the nth term, a plus n minus 1 into d, and we got 10n minus 3. So the nth term is equal to 10n minus 3. Friends, I move on now to the 12th problem, 6a exercise number 12. So please see the 12th problem, problem number 12. I am rubbing this part. Okay, now we focus on the 12th problem. The question is, the last term of the series. The series is given 5, 7, 9 to 21 terms. What is the last term? That is the last term. 21 terms are there. So 5, 7, 9, 11, 13, 17, 19, 21, 23, 25. It goes on till 21 terms. You have to find the last term. Okay. Last term means what? Since there are 21 terms, so it will be T21. We know the formula of Tn is equal to a plus n minus 1 into d. So the formula for T21 will be how much? A plus 21 minus 1 into d. Okay, here a is 5. So I write a equal to 5. And d, what is d equal to? 7 minus 5, 2. 9 minus 7, 2. So d is 2. So I put the formula here, a equal to 5. So I write 5 plus 21 minus 1 is 20 into d. d is 2. So I am getting 5 plus 20 to 2 is 40. That is, I get 45. This is the answer. Please check. Okay, so 21st term, I have to find out. 5, 7, 9 series is given. It is a progression. It is a series sequence and it is an arithmetic sequence because the difference is identical. 7 minus 5 is equal to 9 minus 7 equal to 2. Therefore, we have simply used this formula to find out the nth term T21 is equal to a plus 21 minus 1 into d. So we just put the formula and a is 5, we know d is 2. So we got 45. I think clear. Fine. Now let's proceed to have a look at number 15. Okay. Number 15. Here we will learn a small thing, that is arithmetic mean. So we look at number 15. Okay. Let's try this. See, if I say that there are, we have a term, say we have 10 and 18. Okay. There is a gap. Okay. So if I say that, can you insert an arithmetic mean between 10 and 18? So we have two numbers, 10 and 18. Can you insert an arithmetic mean in between 10 and 18? Okay. So if I put x here and x is an arithmetic mean. Arithmetic mean. You know mean means average. Okay. Mean, M-E-A-N. Normally we use mean for negative. Mean-minded person. Mean-minded means, mentality is not good. Mean-minded. Narrow-minded. But mean in mathematics means average. Arithmetic mean, geometric mean, harmonic mean. So this means average. So arithmetic mean is arithmetic average. So if I insert x here, then the formula will be x will be the average of 10 and 18. Okay. So x will be equal to the average. Average means 10 plus 18 by 2. Okay, it will be half average. So this will be 28 by 2, that is 14. So this is the concept of arithmetic mean, right? And please remember that if x is 14, here, that means what? That means 10, 14 and 18. Do you see some order? Do you see some trend in these three terms, 10, 14 and 18? I think you do. Because 10, 14 and 18 are in AP. Because 14 minus 10 is 4, 18 minus 14 is also 4. Right? So this is the concept of arithmetic mean. Now if you see number 15, okay, let's see number 15. Question number 15, 6A, exercise 6A, question number 15. Two numbers are given, minus 6 and 14. You have to insert two arithmetic means. That means you have to insert 1 and 2. Two numbers between them. Okay. How to do? Two arithmetic means between minus 6 and 14. So, let's do one thing. There are two ways of solving this problem. I am showing one example and the second way I will show in some other numerical. Okay, there are two methods, method 1 and method 2 of solving these type of problems, where you have to put two numbers are given and you have to insert arithmetic mean into the numbers, in between the numbers. Okay, so normally there are two methods for solving these type of problems. I am now going to demonstrate one method. The second method I'll do in some other example. Okay. This is exercise 6A 15. So what I do here is, two means have to be inserted. Right. So what I do is, let the means be A and B. Okay. So A and B will be inserted. Okay. Now, A and 14 and B, can we say that, like we saw the example 10, 14 and 18. Okay. So 14 is the average of 10 and 18. 14 is the mean between 10 and 18. So can I say that B is the mean of A and 14? Can I say that? B is the average of A and 14? If so, then I get the equation B equal to A plus 14 by 2. Similarly, minus 6, A and B. In these three numbers, if A is in between, A is the middle number, A is between minus 6 and B. So A has to be the mean of minus 6 and B. So I can write that A is equal to minus 6 plus B by 2. So I am getting an equation here. This is equal to B minus 6 by 2. And here I have got B equal to A plus 14 by 2. So I am getting two equations. Two linear equations. First, here I am getting 2A cross multiplying is equal to B minus 6. Or I can put it in this way, B is equal to 2A minus 6. From here I am getting cross multiplying A plus 14 equal to 2B. So I can say that 2B equal to A plus 14. I am getting this equation. I am getting B equal to 2A minus 6, and here I am getting 2B equal to A plus 14. Here I am getting only B, but here I am getting 2B. So if I multiply this by 2, I am getting 2B is equal to 4a minus 12. And here I have got a plus 14. 2b, 2b. Here 2b equal to 4a minus 12. Here 2b equal to a plus 14. So I equate them. I write 4a minus 12 is equal to a plus 14. Fine. Which means 3a equal to 14. 3a is equal to 14 plus 12 by 3. 14 plus 12, sorry, 26. Just check. Let's try once again. So we have got b minus a is equal to b minus 6 by 2. So 2a equal to b minus 6. And here we have got a plus 14 by 2 equal to b. So 2b is equal to a plus 14. From here, if you solve, we are getting, just check, 2b equal to a plus 14. Here we are getting a is equal to 2a is equal to b minus 6. So from here we are getting b equal to 2a. No, this will be b is equal to 2a plus 6. Yes, just fine. B equal to 2a plus 6. 2a plus 6, and therefore this one will be 2b. 2b will be equal to, just check, during this sign changes and when you shift from left to the right, lot of errors can come. So let's see once again the equation. A is equal to b minus 6 by 2. So by cross multiplying we get 2a equal to b minus 6. Fine. So b is equal to 2a plus 6. This is fine now. Here we have got a plus 14, 2b equal to a plus 14. Fine. Okay. So I have got 2b equal to a plus 14. Here I have got b equal to 2a plus 6. So what I do is I just multiply 2. So I get 2b equal to 4a. 2 into 2 is 4a plus 12. So I get 4a plus 12 here, and I get 2b equal to a plus 14. So now the equation is 4a plus 12 is equal to a plus 14. Which means 3a. 3a equal to 14 minus 12, that is 2. So a is 2 by 3. So we are getting a equal to 2 by 3. If a is 2 by 3, then from this equation, if you put 2 by 3 here, b will come to 22 by 3. Okay? So we have got the value of a and b, that is the two means which can be inserted between minus 6 and 14. So a is coming to 2 by 3 and b is coming to 22 by 3. 22 by 3 means 3 7s are 21. 7 whole 1 by 3. The answer is 2 by 3 and 7 whole 1 by 3. So this is how we insert two means in between the given numbers. This is first method. There is another method which we will take up in case of some other problems. Okay. Now let us see problem number 16. So this was 15. Now we go to exercise 6a. The same exercise. We are proceeding to solve number 16. Okay. We have another 10 minutes left. We will solve and complete at 4 o'clock, and then we will take some remaining questions from the last day, some responses to the last day's questions. Fine. Otherwise, this chapter is not going to give you any trouble. It's a simple chapter, two simple formula, and we are just doing as much of practice as possible. So now let's take up number 16. Okay. So please note this is number 16. Exercise 6a, number 16. The sum of three integers in AP is 15. So sum of three numbers in AP is equal to 15 and their product is 80. Their product is 80. What are the numbers? You have to find the numbers. So there are three numbers which are in AP and their sum is given and their product is given. You have to find the numbers. Okay. So let us take the numbers. One is A, one will be A minus D, and one is A plus D. Three numbers. A minus D, A and A plus D. These are in arithmetic progression. Why? Because the difference between each of them is d. Okay? This plus d gives you a. This plus d gives you a plus d. Fine. Now, the sum of the three numbers is 15. Fine. So, a minus d plus a plus d equal to 15. This is given in the problem. This means a minus d plus a plus d. So, plus d minus d cancels out. You have a. So, 3a equal to 15, which means a equal to 5. Okay? Now, you know the product. Their product is 80. The product is 80. That means a minus d into a plus d is equal to 80. So, you know a is 5. So, 5 minus d into 5 plus d is equal to 80. 80. 5 minus d into 5 plus d is 80. So, 5 will become 16 here. So, you have 5 minus d into 5 plus d is 16. So, this is of the form a minus b into a plus b. So, this will be 25 minus d square equal to 16. That means, if you bring d square this side, you have d square equal to 25 minus 16. That is 9. So, d is coming to 3. Okay? So, you have a equal to 5 and d is 3. So, a minus d is how much? This is the first number. Second number, third number. A we have already got 5. A we have got 5. So, a minus d. D is 3. So, the numbers are what? 5. 5 minus 3, that is 2. And 5 plus 3, that is 8. So, the numbers are 2, 5 and 8. You can see if you add them, you get 15. And if you multiply them, you get 5 8s are 40, 42s are 80. So, both the conditions in the given problem are satisfied. So, the numbers are 2, 5 and 8. This was example number 16. Problem number 16, exercise 6a. Okay. Right. Now, we take number 19. Exercise 6a number 19. We will do 2 more problems and we will be through with this chapter. So, we are moving in a relaxed manner and making sure that we follow each and every chapter, each and every exercise and concept. Okay. So, let me take number 20 first. This is easy. Number 20. 6a number 20. We will do it in just a few seconds. The arithmetic mean between 33 and 77. What is the arithmetic mean between 33 and 77? Too easy. What is the arithmetic mean? Too easy. So, let it be x. So, the formula is what? X will be equal to 33 plus 77 divided by 2 because mean means average. Right? If I tell you that Ravi has 10 chocolates and say Meera has 6 chocolates. Ravi has 10, Meera has 6. What is the average number of chocolates? So it is 10 plus 6 by 2, 8. On an average 8. Same thing here. If the AM is in between, arithmetic mean is in between, which means this will be equal to 33 plus 77 by 2. So 33 plus 77 by 2. This is 110 by 2. So answer is 55. Okay? I think it's that simple. Hope you are getting confidence on this chapter, right? And this is a scoring chapter, right? So 20 we have done. So number of problems we are doing. Now we will take up, let me see. Okay. Let me take up. Let's take up number 19. Exercise 6a, number 19. This is a bit long. Not so simple, little longer. The pth term of an AP. So TP, the pth term is given, is 3p minus 1 by 6. The sum of the first n terms of the AP is how much? So sum of the first n terms we don't know. So the pth term is given 3p minus 1 by 6. We have to find out the sum of the entire n terms. Okay, now just to quickly recap. TP is equal to, let the first term is A and the common difference is D. So TP will be what? A plus P minus 1 into D. Right? Fine. So let P equal to 5. For P equal to 5. This will become what? A plus 5 minus 1, that is 4D. This is equal to 3p minus 1 by 6. And we'll put p equal to 5. So 3 into 5 minus 1 by 6. That is 15 minus 1 is 14 by 6. So we are getting an equation. A plus 4D is equal to 14 by 6, that is 7 by 3. So 7 by 3. That means 3A plus 12D equal to 7. First. Next, we put P equal to 8. Let's put P equal to 8. So for P equal to 8, what happens? Left hand side becomes A plus 8 minus 1 into D, 8. So 7D, A plus 7D. This becomes equal to what? 3 into 8 minus 1 by 6. So 3 8s are 24 minus 1, 23 by 6. So the equation is 6A plus 6 7s are 42D equal to 23. Okay. So let us see whether we are going correct, and let's just multiply and see. So we have 3A plus 12D equal to 7 and 6A plus 42D equal to 23. So I need to eliminate these two, and once again I am underlining the equations. These are the two equations we have got. 3A plus 12D is 7, 6A plus 42D is 23. The two equations we have got, we need to eliminate. So if you multiply equation 1 by 2, then you will get 6A, and 6A and 6A will get eliminated. So I write, let me just rub up this part. I write here 6A, right? 6A plus 42D is 23. 6A plus 42D is 23, and I write here this into 2. So 6A plus 24D multiplying by 2. 2 3s are 6, is equal to 14. So 6A cancels, so we have 18D is equal to 9. So D equal to half. We are getting D equal to half. If D is equal to half, and if you put the value of D here, A plus 4D is 7 by 3. So D equal to half. If you put the value here, you will get A equal to 1 by 3. So now we have got A equal to 1 by 3 and we have got D equal to half. So what is the sum? Sum we know is the formula. Just quickly recollect the formula. Sum is equal to n by 2, 2A plus n minus 1 into D. So here n we don't know, so we write n by 2, 2A. Now A has come to 1/3, so 2 into 1/3, 2 by 3 plus n minus 1, let it be like that, n minus 1 into D. D is how much? D has come to half, so this is half. So this becomes equal to, let's simplify this and see what happens. So the sum is 2n, 2 cancels out, so it is n by 3 plus n into n minus 1 by 2. Okay, so n by 3 plus n into n minus 1 by 2. If you simplify this further, we are getting 6. So 2n plus 2 3s are, so 3 into n minus 1. That is 2n plus 3n square minus 3n by 6. 3n square minus 3n plus 2n. So it becomes 3n square. The answer is 3n square minus n by 6. Just check, let me check whether this is correct or not. So we have got b equal to half, a equal to 1 by 3. So we are putting a equal to 1 by 3, 2 into 1 by 3 we have done, n by 2 plus 2a plus n minus 1 we have done into d. So we have to simplify this. We are getting n by 3, n by 2 cancels with this 2, n by 3 plus n into n minus 1 by 2. Just let's see whether we are correct or not. Okay, so if you find out the formula, if you just simplify, you should be getting 2n here plus 2 into 3, 3n square minus 3, 3n square minus 3n, and then you simplify. It should be 3n square minus n by 6. I think A is 1/3, B is half. There is no confusion here, just this part. Okay, so this is number 19. So we have got the sum 2a plus n minus 1 into d. We have derived the value a equal to 1/3 and b equal to half, and then we follow through. Okay. 23, let us check. Okay, let's check this one. 23. This is the last one we are doing. There are 25 problems in this chapter, I think. So we have done quite a lot of them. 23 we are taking up now. Okay, 23. 6a, number 23. The sum of a certain number of terms of an AP. The series is given minus 8, minus 6, minus 4 is 52. So the sum of a number of series is this. You have to find the terms. So the sum of n terms of the series, minus 8, minus 6, minus 4 will give you 52. You have to find n. Okay, so here we can see a is equal to minus 8. Clearly it is given. Common difference d is how much? D is minus 8, minus 6. How do you get minus 8? So d is what? Minus 6 minus 2 equal to minus 8. So let's take this case. Here the common difference is how much? Minus 4 minus 2 gives you minus 6. Minus 6 and minus 2 gives you minus 8. Okay? So here the common difference is minus 2. Just check. Minus 8. First term. 3 minus 1, we say 3 minus 1 is 2, 5 minus 3 is 2. So here minus 6. Minus plus of minus 2. In fact, minus 2 gives you minus 8. Okay? So now question is, what will be the equation here? So first term is minus 8, and how is it increasing? Minus 8, the difference is basically plus 2 because minus 8 plus 2 gives you minus 6. So the common difference which you get here, D, the common difference D is 2. And now let us see what happens. We have to find out the nth term, and Tn we don't know. Tn we don't know, but we know Tn is equal to a plus n minus 1 into d. But they have given us the sum. Right? Sum is given. Sum of all these terms is 52. That means we have to use the term Sn. n by 2, 2a plus n minus 1 into d. N by 2, n we don't know, so n by 2, 2a. So what is a here? A is minus 8, 2 into minus 8 plus n minus 1. So n minus 1 is equal to how much? N minus 1, we keep it as n minus 1. D we will write. So the common difference here is 2. So now we will just check the formula, n by 2, 2a plus n minus 1 into d. So let's check this and see what we get. So minus 8, minus 6, minus 4, the sum is given 52. So this whole should be equal to 52. So we are getting n by 2, here we are getting minus 16 plus n minus 1 into 2 is equal to 52. That is, if you transpose this, you are getting n into minus 16 plus n minus 1 into 2 equal to, this 2 will come up here, 104. Okay, so now it's a question of quadratic equation, because you are getting a quadratic equation. N is here minus 16 plus n minus 1 into 2. Okay, so if you break it up, how much do you get? If you just simplify the equation, you will be getting n squared minus 9n minus 52 equal to 0. N squared minus 9n minus 52 equal to 0. So using, I'm just writing it here, n squared minus 9n minus 52 equal to 0. So this will be n squared minus 13n plus 4n minus 52 equal to 0. That gives you n into n minus 13 plus 4 into n minus 13. That is n minus 13 into n plus 4 equal to 0. So n is equal to 13 or minus 4. But n cannot be minus 4 because minus 4 number of terms has to be positive. So n will be equal to 13. This is number 23. So in this case, it's a quadratic equation. Once you solve it, you get n is equal to 13. Okay. The last one we take 25 and let us solve this one, 25. Okay. Question number 25, exercise 6a, 25. Okay. The sum of the series 3.5 is given, plus 7 plus 10.5 plus 14 till 17 terms. What is the sum equal to? Please note here we have a equal to the first term, that is 3.5, that is 7 by 2, first term. Common difference d. So we can see the difference is 7 minus 3.5. So you can see that it is basically 7 minus 3.5 is 3.5. Again 7 by 2. 10.5 minus 7 is 3.5. So therefore, if you follow 7 by 2, a is equal to 7 by 2, b is also equal to 7 by 2. We have to find out the sum of the series, the sum till 17 terms. So the formula is Sn, that is S17. This will be equal to n by 2. So 17 by 2 into 2a. 2a is 7 by 2. So you have 2 into 7 by 2 plus n minus 1. N is 17. So 17 minus 1 into d. d is 7 by 2. So you have 7 by 2. So let's 2 and 2 cancels out. So you have 17 by 2 outside. Inside you have 7 plus 17 minus 1 is 16. 16 into 7 by 2. So this becomes 8. So you are having 17 by 2 into 7 is a 56. 56 plus 7. 56 plus 7 is 63. So 63 into 17 by 2. 63 into 17, let's do 63 into 17. So 7 3s are 21, 1, 2, 6 7s are 42, 44 and 63. So 1, 7, 1, 0. So you have 1071 by 2. 1071 by 2 becomes 2 5s are 10, 535.5. Yes, you get 535.5. So the answer comes to 535.5. So we started with 3.5 is A equal to 3.5, T equal to 3.5. We use the formula of n by 2, 2A plus n minus 1 into D, and that's how we arrived at the amount is, the answer is 535.5. Okay, so this is this is what we have. Now I'll take up the MTP question. The MTP question we have to take up, and this is the additional questions, MTP May 2020. So please note the MTP question May 2020. So May 2020 MTP. The question number I'm taking is, please check, I'm taking 33, question number 33 of the question paper. MTP question paper, please open question number 33. The first and the last term of an AP is given. First term A is given minus 4 and the last term Tn is given 146. The sum of the terms is 7171. So Sn equal to 7171. What is n equal to? So we don't know n. N we have to find out. So let's see the problem. This has come in the May 2020 MTP. First term is given. Term n, last term is given. The sum of the terms is also given. But we don't know n. So how do we find out? Okay. So let's do one thing. We don't know the common difference. Okay. But we can get two equations. Let's take this one. We know the first term and we know that the term n is 146. Okay. So Tn is equal to A plus n minus 1 into D, where A is the first term and D is the common difference. And this is equal to 146. So we can put A equal to minus 4 plus n minus 1 into D is equal to 146. This is the first equation. That means n minus 1 into D is equal to 146 plus 4, that is 150. So we have got an equation here. N minus 1 into D is 150. From this equation, sum of the terms is 7171. We know the formula is n by 2, 2a plus n minus 1 into D, where a is the first term, D is the common difference, and n is the number of terms. So here if I put n by 2 as it is, a is minus 4. So 2 into minus 4 is minus 8 plus n minus 1 into D. Now this is equal to 7171. So we are getting a huge calculation and two equations. So one is n minus 1 into D, and here we are getting, if you simplify, you are getting from here, if you simplify, you are getting n by 2, so minus 8n by 2 plus n into n minus 1 into D by 2. This is equal to 7171. If you simplify these two equations and solve it, you will arrive at n equal to 101. So you have to solve it by quadratic equation, right? So I just showed you the way. Remaining part, if you just try it out and get back to me next day whether you are getting n should be equal to 101. Number of terms n should be equal to 101. Let's take number 31 now. Question number 31 of the MTP. So you can see the typical questions will be on sum and on the nth term calculation. Okay. Let us take the question number 31. Three numbers are in AP and their sum is 21. So we have three numbers, say A minus D, A and A plus D. So their sum is equal to 21, and if 1, 5 and 15 are added to them respectively, then the numbers will form a GP. So if you add A minus B, if you add plus 1, with A if you add 5, right, and with A plus D if you add 15, then the numbers will be in GP. Okay. So let us assume the numbers are A minus D, A and A plus D. First of all, the sum is 21. So A minus D plus A plus A plus D. The sum of the three numbers is 21. So minus D plus D cancels out. You get 3A equal to 21. That means A is equal to 7. First. Now what happens? Now what happens is you are adding 1 to this one. So A is 7. So A minus D is 7 minus D. You are adding 1 to it. So this becomes a new number. Let's call it X. Then A is here. You are adding 5 to it. A is 7. So 7 plus 5, that is 12. This becomes Y. And you have A plus D. A is 7. So 7 plus D. And you are adding how much? You are adding 15 to this number. 15. So plus 15. This is equal to Z. Now by the question, if you go by the question, these numbers X, Y and Z are in GP. Please note. So this problem is a combination of both AP and GP. Please see the problem once again. Three numbers are in AP, so we have taken A minus D, A and A plus D. Yes, we have got the sum is 21 is given. So A minus D plus A plus D is 21. So 3A is 21, A is 7. Clear. Now if 1 is added to the first number, 5 is added to the second number, and 15 is added to the third number, they will form a GP. So the first number is 7 minus D plus 1. That means it is actually 8 minus D. The second number is 12. And the third number is 7 plus D plus 15. That is 15 plus 7, 22 plus D. So these three numbers, I am underlining the numbers now. Okay, so 8 minus D, 12 and 22 plus D. These three numbers should be in a GP. GP we know if X, Y, Z. Okay, if X, Y, Z are in a GP, right, if X, Y and Z are in a GP, then Y divided by X should be equal to Z divided by Y. Okay, so that means 12, I'll just write here, just rub up this part. So this part I'm rubbing up and just doing the calculations here. That is visible to you. So 8 minus D by 12. 12 divided by 8 minus D. 12 divided by 8 minus D. 12 divided by 8 minus D should be equal to 22 plus D divided by 12. So we are going, if X, Y, Z are in a GP, then Y by X should be equal to Z by Y. We saw that is the common ratio. So 12 by 8 minus D should be equal to 22 plus D by 12. So again, we are getting a quadratic equation. You can see you have to cross multiply. If you simplify this, you will be getting D is equal to, let's try it out and see, 22 plus D and 8 minus D. If you multiply 176 plus 8D minus 22D minus D square. This is this side, so this is equal to 176 plus 8D minus 22D minus D square. This is equal to 12 into 12. So we are cross multiplying. 12 into 12 is 144. So if you bring D square to this side, or if you change the sign, then it becomes D square. This is minus 14D. So it becomes plus 14D. Okay. D square plus 14D plus 144 minus 176 equal to 0. So plus 144 and minus 176 is how much? 32. So it becomes d squared plus 14d minus 32 equal to 0. Just checking. So many sign changes and side changes also. 176 plus 8d minus 22d minus d square. Fine. 176 plus 8d minus 22d minus d square equal to 144. D square we are getting this side. This is minus 14d. We are bringing to this side plus 14d plus 144 and minus 176 is 0. So d square plus 14d minus 32 is 0. Okay. So let us just do the final quadratic. We split the middle term. So let's try in this way. D square plus 16d minus 2d minus 32 equal to 0. So this is d into d plus 16 minus 2 into d plus 16 equal to 0. So d comes to either minus 16 or 2. Okay. So d comes to minus 16 or 2. Now here we know that A has already, we have got A is 5 and D is, we will take 2. We will take this number 2. Okay. So if you take, if D equal to 2 and we know A is 7. So A minus D becomes 5 and A plus D becomes 7 plus 2, that is 9. So the numbers we are getting is 5, 7 and 9. The three numbers we are getting is 5, 7 and 9. Please note, as per the given problem in MTP, question number 31, the three numbers 5, 7, 9, let us see whether it's correct or not. 5, 7, 9, are they in AP? Answer is yes. 5, 7 and 9 are progression and 7 minus 5 is equal to 9 minus 7. The difference is 2. Okay, so 5, 7, 9. It's an AP. If you add 1 to the first number, that is 5 plus 1, it becomes 6. If you add 5 to the second number, 7 plus 5 is 12. And if you add 15 to the third number, 15 plus 9 is 24. Then they will become a GP. Have they become a GP? 6, 12 and 24. Yes, it's a GP. 6 into 2 is 12. 12 into 2 is 24. So the common ratio is 2. So we have done this numerical correctly. This was a cross check. Okay. I think we stop here and I think we have done number of questions from arithmetic progression. We have seen what is series. We talked about, we discussed about progressions and sequences. We saw that sequences means a set of numbers which have some order, which has some sort of trend and which has a pattern. And then we moved on to check what is an arithmetic progression where the difference is same, the difference is constant, and we also looked at GP, geometric progression, because in many cases AP and GP are combined. We did number of problems from exercise 6, A and B, and A, mostly from A of course today, and we also did the MTP question, and it's also true that we covered the formula, that is, you remember the formula Tn, A plus n minus 1 into D, plus we did the formula for the summation where Sn is equal to n by 2 into 2a plus n minus 1 into D, and we also did the formula which are important especially for the first n odd numbers, which is n square, 1, 3, 5, 7, the sum is n square, and we did it for the square numbers 1 square plus 2 square plus 3 square, as well as 1 cube plus 2 cube plus 3 cube and so on. So the AP portion is over. I will now quickly go on to some of our responses to the questions on permutations and combinations. We will take a little bit of time, 15-20 minutes to complete that portion, because number of queries have come. While sending the queries, I will request you to make sure it's a specific query, because please appreciate that we are getting 300 queries. And please make sure the language in which you write is appropriate, because I saw some queries where possibly the language is not a professional language. Make sure you are sending a request to the institute, so the language should be courteous, and make sure that you have some patience, because if there are 300, 400 queries, it is not physically possible to answer each and every query. We have a time limitation. You can see every day we are going beyond 4 p.m. and we are doing extra work to make sure you get as much of inputs as possible. And please make sure that your query is specific, and in those cases where we find many students are having problem about a particular problem, you have some issue about a particular question, then we definitely take it up here for discussion. Okay, so please bear that in mind. I request you to have little more patience, courtesy, maturity and understanding, because you see we are working round the clock only for you, and please appreciate the institute's efforts and the fact that this is entirely for you. It's a free class and entirely for your benefit. Okay. Now the first question has come: how to differentiate between permutation and combination. Mahadevan K, Tanu Tanwar, Kunal, Anupam Arora, Kushi Bhardwaj. Then we have S. Divya Bharti, Shubhasri, Karthik S, Harish from Pondicherry, Jyoti Singh, Samriddhi Chaturvedi, Palak Agarwal, Rutvik Moite. Many names. Now I request you, when you differentiate between permutation and combination, what is the rule? I discussed in detail in the last two sessions that in case of permutations, the order is important. So if I write ABC, then ACB, BAC will be different order. So it will be counted as 3, for example. AB and BA will be counted as 2 in case of permutation. But in case of combination, no. So you have to go through the language of the problem to understand whether the problem is talking about an order which is basically relevant. If the order is relevant, then it will be a permutation problem. If the order is not relevant, well, it becomes a combination problem. Secondly, if relevant, use permutation. Normally for problems involving committee formation, like we did number of problems on committee formation, usually it's combination. If you have a problem on words, like rearranging the letters of a word or rearranging a number, then it is usually permutation. And if you take, for example, photos of, say, 7 people are standing in a row to take a photograph sequence, well, this will become a permutation because you have different people and who stands beside whom is also relevant. Okay, so this will be the general rule. Next is Samriddhi Chaturvedi from Kanpur was asking me once again of explaining factorial. Well, I have done many times. I'm just telling Samriddhi once again. If it is 9 factorial, it means 9 into 8 into 7 into 6 into 3 into 2 into 1. N factorial is generally n into n minus 1 into n minus 2, so on till 3 into 2 into 1. So factorial n, and you know, as I said many times, you must have noted it, that you can write it in 2 ways. If you want to write 5 factorial, can be 5 factorial or 5 factorial, right? Okay. Let me go to the next one quickly. Now there was a question on management. So there was a permutation, a problem involving management, where the word management was written. So some of our friends, Rajal Gupta, Rahul Kumar, Utkarsh from Lucknow, they have talked about how we did it. Once again, the word is management. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters, and we are having multiple letters which are repeating. So here if you see, we are having how many? M is coming 2 times, A is also coming 2 times, then N is coming 2 times, N is coming 2 times, and we are also having E. So here is one E and here is one E. So it is coming 2 times. So we are having 1, 2, 3, 4. Now each of these letters, M, first of all, the 10 letters, if the 10 letters are totally different, if there are no repetitions, then it will be 10 factorial. So 10 factorial. But since there are repetitions, if you find a word which has no repetition, we did some problem like that. Okay. So if you take any word, say you take maths, M-A-T-H-S, maths. 1, 2, 3, 4, 5. Any letter, is it repeating? No. So how to solve this? In how many ways can you arrange the letters of the word maths? There are 1, 2, 3, 4, 5. 5 letters. So straight away 5 factorial. But here, in this case of management, since you are having 2, 2, 2, 2. So mathematics we are having, guys, 2 M. The same letter is coming twice. And the 2 letters M can be arranged between themselves in 2 ways. So factorial 2 comes up. Again for A, factorial 2 comes up. For N, this factorial 2 comes up. And for E, again factorial 2 comes up. So you have to solve this. It's a long calculation, 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 divided by 2, 2, 2, 2. So it will be 16. Please solve for this and see, this is the process and this is the working out. Since all the letters are different, if all the letters are different, assuming that the letters are different, it will be 10 factorial. But since we have letters which are common, 2M, 2A, 2N and 2E, this will go to the denominator because these are repeating letters. If you have, say for example, A 3 times, say A instead of 2 it is 3 times, E instead of 2 it is 4 times, say E is 4 times, then what will happen? For A it will become 3 factorial, for E it will become 4 factorial. If in any word you have, say I take the word just to show you. So this is the way, 10 factorial divided by 2 factorial into 2 factorial into 2 factorial into 2 factorial. Right? 2, 2, 2, 2 will be 2 to the 4 to the 8 to the 16. So 10 factorial by 16, whatever value, just use a calculator. If I give you another word, say excess. I give another word, excess. Excess. What to do? 1, 2, 3, 4, 5, 6. Okay, 6 factorial, fine. But we have 2 E's. So 2 E's. And we have 2S. So 2S. Okay, whatever will be the result. Just use calculator to find out. Right. If I give you another word, say I give you the word, let's take betterment. Betterment. B-E-T-T-E-R-M-E-N-T. We are all working for your betterment. Okay, betterment in life, betterment in your career. So how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters, fine. So it can be arranged in 10 factorial, provided the letters are different. But let's see. E is coming here how many times? 1, 2, 3. Fine, 3. E is done. T is coming how many times? 1, 2, 3. T is coming 3 times. Okay. E and T, okay. E is done, 1, 2, 3. Betterment. Any other letter, just check. N is coming once, M is coming once, R is coming once. So we are having 6. So we have N, M, R and B. Fine. Okay. So this will be a case of 3 and 3 factorial. 10 factorial divided by 3 factorial and 3 factorial. Why? Because E is repeating 3 times, E is repeating 3 times and the 3 E's can be arranged between each other in 3 factorial ways. Same for T in 3 factorial ways. Okay. So I hope this is clear. Utkarsh, Srajal and Rahul, I think you are now absolutely clear about the process. Okay. Calculation, just work on it. Many of the calculations you have to just use a calci and do. Now we take number 19, exercise 5A. This is a critical one, exercise 5A. So I have decided to solve it. Solve it in front of you. Exercise 5A number 19. Many of our friends have requested me to do it. As usual, you can see it is 4:30, still working together. That's why please make sure that you also put in that much of patience, that much of effort, and you must have the understanding also that it's a joint effort, right? Ananya Jain from Ambala City, Tejashwini P from Karnataka, Mitali Jain from Delhi, Shrishti from Haryana, Vanshika from Punjab, Nitin Kumar Agarwal from Rewari. So many people. Question is lovely. Let's do it. The sum of all 4-digit number containing the digits 2, 4, 6, 8 without repetition is what? Terrific problem. See, in permutation combination you are using brain. In AP and GP it's just formula. Right? So what to do this? What to do with this problem? 2, 4, 6, 8. 4-digit numbers. Now there will be number of such numbers. How many numbers can you create? 2, 4, 6, 8. 4-digit number. How many can you create? First of all, let's do this. So, how many numbers will come with the digits 2, 4, 6, 8? So, we know there are 4 digits and in general for permutation n objects can be arranged in n factorial ways. So 4 digits can be arranged in 4 factorial ways, that is 4 into 3 into 2, which is 24. Fine, 24 ways. Please note and please see, that means now 24 such words, letters will be formed, 24 such numbers will be formed. 4 digit, 4 digit, 4 digit, 4 digit, like this it will go. Okay, so I am just trying to draw 24. Say this is 24, just assuming 1, 2, 3, 4, 5, 6, 7, 8, 19, like this, 24. Okay, 24. Now see the point. This is the intelligent part. Now 2, 4, 6, 8, different combination will come, which means this, if you look at this particular units place, I am just using this red color. If you use this part, this particular part, the last row, the last column, in fact here, column, the last column if you check, what will you see? You will get 2 also, you will get 4 also, you will get 6 also, you will get 8 also. Altogether 24 numbers you will get, 24 numbers. So this row, this column will comprise of digits which are 2, 4, 6 and 8. And 2 will appear 6 times, 4 will come 6 times, 6 will come 6 times, 8 will come 6 times. In altogether you will get 24 combinations. So this column will be comprised of 24 digits. Out of the 24 digits, 2 will come 6 times, 4 will come 6 times, 6 will come 6 times and 8 will come 6 times. So if 2 comes 6 times, you get 12. If 4 comes 6 times, you get 4 6 are 24. If 6 comes 6 times, you get 36. Plus 8 coming 6 times, 8 into 6 is 48. So when you are adding this number, the question is, what is the sum of all these numbers? So I am adding this row. When you add, for example, 3 1 6, 4 2 4, 4 2 9, 7 1 7. When you add, what you do? You first take the units place, 9 plus 6 plus 7. 9 plus 6 is 15, 15 and 7 22. 2, carry forward 2. 2, 3, 4, 5, 6 and then you again add. So it is 10 and 14, 14, 62. Same thing we are doing. We are first adding the units place. Then we will go to the tens place. Then the hundreds place, then the thousands place. Because there are 4 places. Okay? Now please see. The units place, last column, you will have 12 plus 24 plus 36 plus 48. This will be the sum of the units place. 12 plus 24 is 36. 36 and 36 is 72. 72 plus 48. 72 plus 48 is how much? 72, 48. 10, 120. So 120. So 0 will come here. 0 will be the last. So I am doing the sum now. Sum. So 0 here and 12 will carry forward. Will go here. Similarly in the tens place, see the total is coming to 120. Again the total will come 120. Because in the tens place also, there will be 24 digits, out of which 2 will come 6 times. 4 will come 6 times. Equal distribution. 6 will come 6 times, 8 will come 6 times. 6, 6, 6, 6. 6 4s are 24. Okay, it's a lovely problem, but definitely a tough problem because it's doing it under exam conditions. It is not a joke, this problem. That's why I'm taking it up. I could have sent solution directly. You will not understand if I directly send. Explaining is more important. Sending a solution, Excel sheet and just doing it like that is not the way. You will never learn. This is the way to learn. Okay, so here 120 is a 0 here. 12 carry forward. Again this column if I add will be 120. But I have 12 here. So 120 plus 12 is 132. So when you have 132 here, 2 will come here. 13 will carry forward to the next hundreds place. Again in the hundreds place, there will be 120. Plus this 13, 133. So 3 will go and 13 will go to the next carry forward. Here again it will be 120 plus 13, that is 133, so it will be 133. So the sum will be 133320. 133320. This is one of the toughest problem. I hope this is clear. 5A number 19. One of the best problems and a very intelligent problem which is there in the study material. That's why I took it, because so many of your friends, I have mentioned Ananya, Tejaswini, Mitali, Shrishti, Vanshika, Nitin, their names. So many people could not do it. Okay. Now let us quickly go to one or two other problems before we wind up. Okay. So you can see we are taking over time to make sure that you are through with the earlier questions. Okay, there's a question from Dareen Chand from Lucknow. Number of arrangement of 5 things taken out of 12 things. 5 things you are taking out of 12 things, in which one particular thing will always be included. Now we did a formula, Dareen, you must have seen. The formula is R into N minus 1. P into R minus 1. So in this case, what will happen is 5 things out of 12. So one thing will occur continuously. So here one thing is going to occur continuously. Okay. So here you just put in the formula. 12 minus 1 is 11. So 11 P. R minus 1 is 5 minus 1 is 4. So you write 4 here. R minus 1. You want to bring out 5 things and 5 into 11P4. Okay. Next we have, from Anjali Priyadarshini, 5A, question number 21. Let's go to exercise 5A, number 21. 4-digit number, exercise 5A, number 21. Please note. The request has come from Anjali Priyadarshini from Odisha and Kajal Prajapati. For this question, 5A number 21. 4-digit numbers to be formed out of the figures 0, 1, 2, 3 and 4 such that no digit is repeated. How many numbers can you form? 4-digit numbers to be formed out of the figures 0, 1, 2, 3, 4 such that no digit is repeated. So you have 4 digits. Okay. Now question is, first digit, how many choices do you have? It has to be a 4-digit number. So if you start with 0, no, it will not be a 4-digit. You can start with 1, you can start with 2, 3 and 4. So you have 4 options. So I write 4. Now you have the second digit. Out of the 4 options, 1 is gone. So you have 3 options. Plus 0 also can come here. So here also you have 4 options. For the tens place, it will be 3 options. And for the units place, it is 2 options. So please note, dear friends, this is a case basically permutation, not combination, permutation. Also please note, in this case, we use the multiplication formula. It is not the addition, because 4 different events we are doing. We are filling these gaps with numbers. Okay, so we are just multiplying 4 into 4 into 3 into 2. 4 4s are 16, 3s are 48 into 2, 96. So the answer should be 96 ways. Okay, we have done this. Next is from example number 23, exercise 5A, number 23. Okay, just quickly complete the remaining ones. This request has come from Aruna Suresh from Tamil Nadu and from Meera from Tanjore. Aruna Suresh and Meera. 5A23. The word is daughter. T-A-U-G-H-T-E-R. The word is daughter. If the letters of the word daughter are to be arranged so that the vowels occupy the odd places, then what is the number of different combinations, different words? So we have daughter, let us see how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. We are having 8 letters. 8 letters. Now, which are the odd ones? Which ones are the odd places? So you have the odd places, even odd. So odd. Again odd. You have odd. Okay. So sorry, odd, even, odd, even, odd, even, odd. So you are having 1, 2, 3 and 4. The question says that the vowels will occupy the odd places. Vowels, so this has to be taken by a vowel, 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 vowel. How many vowels do you have? A, U, E. Anything else? One? No. So you have A, U and E. So you have 3 vowels. Okay? So question is, you are having 3 vowels. 3 vowels and 4 places. 3 vowels and 4 places. And then remaining you have 5 other letters. 5 other letters. So you have B here, G, H, T and R. Very good. So you are having 4 places and you have 3 vowels. In how many ways can you arrange? So it is basically 4 places and 3 vowels. Okay? So it is 4P3. Now you have how many places left? You are having 5 places and you have 5 other consonants. They are other letters but not vowels. They are consonants. Right? So it will be 5 factorial, or it's 5P5, whatever you call it. Right? 5P5. So let us compute 4P3 is how much? 4 factorial by 4 minus 3. That is 1 factorial into 5P5. So 5 minus 5 is 0 factorial. So you have basically 4 factorial into 5 factorial. So 4 3s are 12 into 24 multiplied by 5 factorial. 5 factorial is 4 3s are 12. 5 into 4 into 3 into 2. 5 4s are 20, 3s are 60, 2s are 120. So it is 120 into 24. So let us calculate 24 into 120. 24 2s are 48, 24 1s are 24. 288 and this 0. 2880. So the answer is 2880. Okay, please check this question. Question is 23 and example exercise is 5A. Daughter, we have taken A, U and E. A, U and E can be kept only in the odd places. So odd is 1, 3, 5, 7 positions. Okay. So 4P3 because you have 4 vacancies and 3 letters. 4P3 we have done. Remaining 5 letters which are there, which are the consonants, they can be placed in this particular way. Okay. Now we take another tough one. Okay. And this is page number, exercise 5A, number 11. 5A number 11. Again, the idea is to make you understand, even though the question has come from many of you, Palled Bhavana from Karnataka, Supriya Saha from Jharkhand, Anjali Priyadarshini Sahu from Odisha, and Ubba Ruben from Vizag. But the idea is to solve it here. If I send the solution in an Excel file, others will not understand. That, like the one you saw, 2, 4, 6, 8, the way I analyzed. I tried to analyze it in front of you, how the sum is coming to that huge number. So if I just do it in an Excel sheet, no. I mean, we are taking extra time only for the purpose so that query can come from 3 of you, a question can come from 5 of you. But I am trying to solve it so that it will help the others also. Please don't think that my query, if I send a query, my query cannot be your query. You may have the same query. Maybe these people have written to me, so I come to know of it. But it has to be done so that everybody benefits. Right? That is why we have to solve it here. This is a tough one. Once again, like you saw that 2, 4, 6, 8, the sum, it is a tough one. This is a tough also. Exercise 5A, number is 11. Please note the problem. M plus N, P2 is equal to 56. M minus N, P2 is equal to 30. So, what to do? M plus N, P2 equal to 56 and M minus N, P2 equal to 30. So, we have to find out what will be the value of M and N, right? So, let us try and see. M plus N, P2 is 56, M minus N, P2 equal to 30. We have to find M and n. We don't know the value. This is little bit of challenging, so we are doing it. Let us use the fundamental formula of permutation. So we have m plus n factorial. NPR means n factorial divided by n minus r factorial. So m plus n factorial, in the denominator it will be m plus n minus 2. This is equal to 56. Fine. First equation. Okay. So if you just break it up, what do you get? M plus n means, m plus n factorial means what? M plus n into m plus n minus 1. Then we have m plus n minus 2 factorial. This divided by m plus n minus 2 factorial equal to 56. So here I cancel this 2. So you are left with m plus n into m plus n minus 1 equal to 56. Please note the equation. M plus n into m plus n minus 1 equal to 56. This is the equation. This is the equation. Now, we take the second one. So I am rubbing this part. I keep the equation as it is, but I am rubbing this part. Okay. M minus n P2 equal to 30. So this gives me m minus n factorial NPR. NPR is n factorial divided by n minus r factorial. So n factorial we are done. Now m minus n minus 2. M minus n minus 2 factorial. M minus n minus 2. This is equal to 30. M minus n means actually what? M minus n into m minus n minus 1 into factorial m minus n minus 2. And in the denominator you have again factorial m minus n minus 2. This is equal to 30. M minus n minus 2 cancels with m minus n minus 2 factorial. They are cancelled out. So here you are getting the equation m minus n into m minus n minus 1. M minus n minus 1 equal to 30. Please see the equation. So we have got two equations. So I am rubbing this part again so that we can clearly see the way in which we are moving towards the solution. Okay. So we are having two equations, m plus n into m plus n minus 1 equal to 56. First equation. The second equation is m minus n into m minus n minus 1. M minus n minus 1 equal to 30. Now you see, further use of brain, you have to use your intelligence. So what I will do is let m plus n equal to x. Let m plus n be x and let m minus n equal to y. I am substituting m plus n for x and m minus n I am making it y. I am trying to simplify because this is a big expression. M plus n into m plus n minus 1. Again m minus n into m minus n minus 1. Unmanageable, very big. I am trying to simplify it. So I am writing m plus n equal to x, m minus n equal to y. So now the above, the first equation which you see, it becomes simplified. It becomes x, m plus n is x, into m plus n, x minus 1. So x into x minus 1 is 56. Similarly, the second equation if you see, what I am doing is, I am doing m minus n is y. So y into y minus 1 equal to 30. Okay. So now we can see that we are getting two equations. So let us take the first one. X into x minus 1 equal to 56. I am taking this one. Here. So this is what? X square, x into x is x square minus x minus 56 equal to 0. Please check. Quadratic equation. X square minus x minus 56. 56 comes to the left hand side. Okay, it becomes equal to 0. We are splitting the middle term. This is ax square plus bx plus c. It is a quadratic form. We split. So it becomes x square minus 8x plus 7x minus 56 equal to 0. So this becomes x into x minus 8 plus 7 into x minus 8 equal to 0. So if you simplify this, it becomes x minus 8 into x plus 7 equal to 0, which means x is equal to 8 or minus 7. X is equal to 8 or minus 7. It's a very complicated problem. X is equal to 8 or minus 7. So I am writing x is equal to 8 or minus 7. Fine. Okay. The question is x is equal to m plus n. In combinations and permutations, do you have minus figure? No. So we will take it up in an instant. Now this is done. X is equal to 8 or minus 7 I put here. Now I will take the second equation. Just see the amount of effort which goes into one problem, solving one problem. Tough problem like this. Now we take this one. Y into y minus 1 equal to 30. So you expand it. Y square minus y minus 30 equal to 0. Split the middle term. Y square minus 6y plus 5y minus 30 equal to 0. So taking y common, y minus 6 plus you take 5 common plus 5 y minus 6 equal to 0. So you are getting y minus 6 into y plus 5 equal to 0. Sorry. So y is either equal to 6 or y is equal to minus 5. Okay. So from here you can see that minus values we will not take. So I am running this part again. See the length of the problem, see the complexity of the problem. Of course, if this problem comes in the exam, it will be a challenge for many of us. Many of us who are appearing for the exams. Okay? But we should know the way. We have to win. We must know the process. And you can see this is not a calculator one. Calculator one I am leaving. I am not doing full calculation. You can work it up. But here it's not a calculation. It's plain intelligence. So we have to work till the solution. If there is a long combination, I am leaving it up. You just use the calculator. I will show the process. I will do the number work. Okay? But for these type of problems, we have to go till the end because it is intelligence, not computation. Let's see this one. So we have got x is equal to 8 and y equal to 6. But we know x is m plus n. So we write m plus n equal to 8. Y is m minus n. Minus n. So m minus n equal to 6. So n and n cancels out. You have 2m equal to 14. That is m equal to 7. If m is 7, okay, so we know if m is 7, m plus n equal to x, m plus n equal to x is 8. And if m is 7, so n has to be equal to 1. So the final answer is m equal to 7, n equal to 1. So that is why this example, page 5.8, this example number 11, the question number 11, exercise 5A, terrific problem. That's why you have to see the step-by-step solution. And why we took x for n plus 1 is to simplify. You cannot deal with such big numbers. Make it simplified, make it shortened, solve it, then expand once again and go back to the original answer. Okay. Last one I am doing, time is almost running out. I will just take the last one or maybe last two problems. Some of the problems are very lengthy, you can see, and real tough problems and a lot of things to understand. Okay, I am taking the problem exercise 5B and the problem number is 19. Okay, this has come from, I am taking those problems where multiple people have problems. Multiple people could not solve it. They have sent requests. Okay, so Tejaswini P from Karnataka, Kajol Singh from Rajasthan, and Anushka Mishra from Delhi. Okay, so we deal with almost 300 of your, at least 300 to 400, messages keep coming every day after the class. It becomes a big job for us to analyze, understand, sort out. Many of them are not technical queries, right? Then we find out which questions are actually creating trouble for you If majority people have problems, if 3, 4, 5 people have problems, we take it up for solution. In this way, we have to sort out. It's a long job. And anybody sending a message does not mean that your message will be taken on the same day. We keep a track, but it's not possible. So individual query is very difficult to answer. Please understand the time limitation. It's already 5. We are still pushing. Right? So let's solve this one. Number 19. The total number of ways in which 6 positive signs and 4 negative signs can be arranged in a line such that the 2 negative signs will not occur together. So you have 6 positive signs, plus signs, and 4 minus signs. 6 plus signs and 4 minus signs, you have to arrange them in a line in such a way that 2 negative signs will not occur together. Now here if you see the way to arrange, because you know permutation is an arrangement, combination is an arrangement. So let us see the way. So here the only way, so let us draw 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. So we can put it in this way, minus, plus, minus, plus, minus, plus, minus, plus. So we have 6 positive. So 1, 2, 3, 4. Minus, plus. Okay, so we have 1, 2, 3, 4, 5 and plus. Okay. That means just taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and then we have one more 13 because you can place minus here also. So idea is that they are standing in a row. You have the positive sides here 1, 2, 3, 4, 5 and 6. The positive signs are here. And the negative signs, 4 negative signs, you can place them either here. So I am drawing with a star, or here, or here, or here, or it could be here, or it could be here, or it could be here. So altogether if you see, you are having 4 negative signs, but the number of places, the number of positions where you can make them fit is 1, 2, 3, 4, 5, 6 and 7. 7 places where you can put these 4 negative signs. So in how many ways can you do it? If you have 7 places and you have 4 negative signs, how many ways can you fit? It's a case of permutation. 7p4. Okay. Now just check. Sorry, combination. C4. 7c4. Okay. Now the question is, since you are having these places, now ultimately you are having these, if you place these positions here, total number of ways is 7c4. So automatically the others will be arranged. So if you can arrange them in this way, because it's a case of, you can see combination because you have the order is identical numbers. Minus signs are identical. So if you can place them in this way, automatically the positive signs will be fitted. Now this 7c4, if you calculate 7 ncr, that is n factorial, r factorial and n minus r factorial. So it is 7 factorial divided by 3 factorial into 4 factorial. So this comes to, just calculate 5, 6, 7, 5 into 6 into 7, by 3 into 2, 3 into 2. So 3 2s are 6, 3 into 2, 7. So it is 5 into 6 into 7, 3 2s are 6, 2 2 cancels out, 35. Okay, so it will be 35 ways in which this arrangement can be done. This is question number 19, 5. Once again, let me check 5b. Okay. Now, last 2. Just we'll take quickly the last 2. So already 5. Let's take 5b number 16. 5b number 16. Last 2 we are taking and then we are winding up. Exercise 5b number 16. Raghav Saluja from Delhi has requested me to take this up. There are 10 trains between Calcutta and Delhi. The number of ways in which a person can go from Calcutta to Delhi and return by a different train. It's a fundamental principle. You can go from Calcutta to Delhi. How many trains are there? 10 trains. So for the event 1, E1, that is going from Calcutta to Delhi, you have 10 ways. For the second event, E2, for second event, E2, returning from Delhi to Calcutta. So this time it is Delhi to Calcutta, D to C. But you have to come back by a different train. So while coming from Delhi to Calcutta, you have 9 ways. Because 10 ways, 1 way is gone. So you have 9 ways. So since E1 and E2 are interlinked, they are dependent events. One depends on the other because I can only return from Delhi to Calcutta if I go first from Calcutta to Delhi. So they are totally dependent on each other. They are not isolated events. They are connected events. So we use the multiplication formula and this becomes 10 into 9. So 90 ways of doing it. Going to Delhi and coming back to Calcutta 90 ways. Okay. This is 5C. This is the last one for today and we end with that. So 5C number 9. Exercise 5C number 9. Okay. Exercise 5C. Number is 9. The question is a committee of 3 ladies. This has come from K. Shweta Priya. K. Shweta Priya from Karnataka. A committee of 3 ladies and 4 gents is to be formed. So 3 ladies and 4 gents is to be formed from 8 ladies. 8 ladies and 7 gents. Fine. Now Mrs. X refuses to serve in a committee in which Mr. Y is a member. So they have some problem with each other. They don't want to be in the same committee. Mrs. X refuses to work in the same committee where Mr. Y is a member. How many such committees can you form such that Mrs. X and Mr. Y will not be in the same committee? This is not an easy one. Little bit of challenge, little bit of trick. In this type of cases, what we do, we first find out the total number of cases possible, n, minus the number of cases where Mrs. X and Mr. Y are always together. So, where X and Y are always together, Mrs. X and Mr. Y are always together. So, total number of possible cases minus the number of cases where X and Y are together. If you deduct, then automatically you can get the number of cases where Mrs. X and Mr. Y are not together. Okay, so this is what we are trying to do. So this is the trick or this is the shortcut you can call it. Now, if you want to see the number of ways in which these people can be arranged, that is 3 ladies can be selected from 8 ladies and 4 gents can be selected from 7 gents. Is it permutation? Is it combination? Committees. So whether Hari and Ashish are selected or whether Ashish and Hari selected doesn't make a difference. The order is not relevant. The order does not matter. So it is a case of it's a case of combination. Therefore, what we do in this case, let's find out total number of possible cases. 3 ladies from 8 ladies. So it will be 8C3. Okay, 8C3. But you also need to select 4 gents out of 7 gents. So it is into 7C4. Let's quickly work it out. This will come to 8C3. So 8 factorial, 5 factorial and 3 factorial. So it is 6 into 7 into 8 by 6. So it should be 56. 56 into 7C4. 556 into 35. This is the total number of cases. 56 into 35. This gives you 1960. 1960 total number of cases. Okay. 1960 total number of possible cases. Possible. Now what we do, we find out the number of cases where X and Y are always together. Now, if you want to find it simple, we have a formula. What we do is we just find, in this particular case, 7C2. From 8C3, we deduct one person because she is always there. So it becomes 7C2. That is n minus 1, C R minus 1. N is 8. R is 3. So n minus 1, 8 minus 1, C, R minus 1, 3 minus 1. So 8 minus 1 is 7, 3 minus 1 is 2. Okay. Similarly for the gents, assuming Mr. Y is always there. So it will become again n minus 1, R minus 1. So it is 7 minus 1, that is 6C. 4 minus 1, that is 6C3. Okay, so this is the formula. 7C2 and 6C3. Let us quickly see what is the calculation. It's just 1 minute more. 7C2 and 6C3. Let's work together. 7C2. 7C2 means 4 and 2. So it is 5 into 6 into 7 by 2. 2 3s are 5 3s are 15, 7 is 105. So 105 and 6C3. 6C3. 3 3 4 5 6. 6 cancels 20. So 105, just a sec. 7C2 into 6C3. Once again, let's check. 7C2. 7C2 is 7C2 4. No, it's 5. 5. 7C2 is 7, 5, 2. Okay. So it is 6 into 7 by 2. 2 3s are 21. Sorry, this is 21. 21 and 6C3. 6, 3, 3. So it is 4, 5, 6 by 6. 6, 6 cancels out. 4, 5 is 20. 21 into 20 is 420. 420. So we have 1960 total cases. 1960 total cases. Total possible cases 1960 and 420 cases where X and Y will always be together. That is Mrs. X and Mr. Y will always be together. So if you deduct from 1960 minus 420, you get 1540. 1540 cases where Mrs. X and Mr. Y will not be together. That means the condition given in the problem that you have to create a committee of 3 ladies and 4 gents from 8 ladies and 7 gents such that Mrs. X does not appear in the same committee with Mr. Y. This will be satisfied in the case of 1540 such cases. Okay, so this is the solution to the last problem. With this, I think we end up. I also got some questions from Ashrita Jain regarding whether PNI value will be given. Vanshika, she was asking about whether you can prove 0 factorial is 1. Long calculation, but since we discussed earlier, it's beyond the scope of our discussion. So far as the syllabus is concerned, by convention 0 factorial is 1. Anushka's problem I solved. Madhusudhan Kabra, can we do factorial of a decimal number? No. Harsha Gupta, I think 5A number 12 done in the last class. Utkarsh was asking whether rough sheet is given, usually given. Simran Garg also had a question regarding her studies. I requested her to talk to BOS directly. Muskan Garg, sir, do we have to solve factorials? 8 into 9 factorial. Now, see the options given. If the answer is given in terms of factorial, then you don't have to break the factorial further. But if you see whole number is given, that means you have to break it. Depends on the question. Lakshmi from Palakkad, how to calculate 1.05 to the power n equal to 2. 1.05 to the power n equal to 2. Well, you have to go on calculating 1.05 into 1.05 into 1.05 unless the results come to 2. Then you can find the value of n. Kirtana from Chennai, she is asking whether there is a solution book for ICAI study material. No. And Gudniya Jatin from Hyderabad asking whether there is any theoretical question in MCQ. Sometimes it comes, normally not. Utkarsh from Lucknow usually computes problems. I can see his continuous effort. Good, Utkarsh. Now, whether there will be any test in which you can evaluate your performance, definitely the mock test will be there. Please participate in the mock test to see where you stand. Shiva Sankaran, any question regarding theory paper? Normally, theory questions are not asked, but go through the formula. Similarly, I think Akash had a question. I have answered it. Amanta Varghese, how to identify permutation and combination? I think I took up and discussed about it. Rohan Konda from Karnataka. Sir, whether n is positive integer or what? Yes, in permutation combination, n has to be positive integer. It cannot be negative or fraction. Tejashree, I have answered your question. I have already sent it. Arthas from Canberra. How many sums will come from the chapter? Around 3 problems usually comes from permutation combination. Question from Pooja, I have answered back. Mehul Khemka, thanks Mehul for your comments. Utkarsh, thanks for your comments. Similarly, Bharat from Kerala, if the question is not saying whether digits are repeated, can we assume it is repeated? Yes, we assume it is repeated. Aditi Shah, your question I have already applied. I think I have solved it. Similarly, Kartika, thank you. Naya Balam, thanks for your comments. Chaitanya, thanks for your comments. Ritika, thanks. Kevin Mojaria from Gujarat, thanks. Rohit Agarwal, thank you. I think this is all I wanted to say and respond to. We have done a lot of numericals, additional problems from exercise 5A and 5B, also from 5C. So we come to the end of the session today. Go through the questions on the arithmetical progression part, 2 simple formula. Next day we'll meet again and we'll take up the GP. Till then, thanks a lot for being there. Work hard and you will be successful. Signing off today. Bye.